Hi and welcome to this course Functional Programming with Elixir. Now this course is all about learning the fundamentals of functional programming, and we are going to learn these fundamentals by using the Elixir programming language. Now this course is for someone who has some basic knowledge of programming, but you don't need to be an expert. Maybe you know a little bit of JavaScript, Python, Java or C++, it doesn't matter, but you do need to have some kind of programming experience. Now let us go through all of the topics that we would be covering inside this tutorial series. So the first thing, as you can see, that we are going to learn all of the basic fundamentals of functional programming, and after that we are also going to learn all of the basics of Elixir. You can see that we are going to cover all of the type system of Elixir as well. Then we will see how to create projects by using Mix. So this is the basic tutorial project that we are going to create, and as a last capstone project we are going to create an actual statistics library. Well, that's it for this video. I hope you are excited to learn more about functional programming and Elixir in general, and I will catch you in the next video. So what exactly is Elixir? Now Elixir is a functional programming language. Now why am I talking about Elixir? Well, let me answer this by asking you a question. When was the last time you used WhatsApp or Discord? Well, both of these applications, they run on the same virtual machine. Now, to be precise, Discord is powered by Elixir and WhatsApp is powered by Erlang. You must be thinking what Erlang has to do with Elixir. Well, Erlang is also a functional programming language, and Elixir is built on the top of Erlang, and both of these languages, they are compiled and they run on the Erlang virtual machine, which is also called as the Beam. You can imagine this to be similar to your Java virtual machine. You have so many languages such as Java, Kotlin, Clojure and Scala. All of these languages, they compile and they run on the Java virtual machine. The same thing happens with Elixir. Elixir gets compiled and it is run on the Beam virtual machine. Now you must be thinking, why is all of these things important? What's so great about Elixir? Well, first, it is functional. Second, it supports immutability by default. Now why is immutability so very important? Well, because of that we can have immense scalability. You must be wondering why. Because since all of the data types is immutable, that means there is no chances for the threads or some other objects or maybe some other functions to accidentally change the values. So the state is preserved, and that's why the systems becomes much more scalable. And the most powerful thing about Elixir is that it supports fault tolerance. Suppose any of your node goes down or any of your actors or processes goes down, then automatically they can be revived, and they can be revived with its own state. So that's why you can create immensely distributed and fault tolerant systems by using Elixir. So if you're interested in learning Elixir, then stay tuned and I will meet you in the next video. Bye. So now we know a little bit more about Elixir, but let us try and understand what do we mean by functional programming. In simple terms, it simply means that our entire program is composed of different functions. So just imagine that this f of x is a kind of a function. So let me highlight the background. So this, the green thing, so this is a very simple function. Now this function, it gets an input. Suppose that input is an x. Now this function is going to transform that data from x, and that data would be transformed to something called as y. So this is what your function is going to do. Your function will always accept some kind of an argument. It will transform the data and it will always give you back some kind of data. Now this may look very simple, but it's not so simple. There are a lot of things that go behind creating your pure functions. So let us try and understand what makes functional programming so unique. The first thing is obviously we don't have any classes or objects inside functional programming. The next one is all of the data type is immutable. So it's just like working with constants throughout your program. Now you must be wondering, why do we need immutable data types or constants? The answer is, since the data is not mutable, that means the state remains the same. And if the state remains the same, that means that data can be copied and it can be distributed much more easily. And since this data can be distributed, that means we can create immensely scalable systems by using functional programming. Now this brings me to the next point, and I think that this point is going to shock a couple of us, and that means we don't have any for loops. Now since the data is immutable, that's why we don't have for loops. Just try and imagine your typical for loop. Suppose you have your variable of I equal to 0, I which is less than length, and I plus plus. Now what's happening is, for each iteration your variable of I is increasing. That means the data is constantly mutating. But we can't have that because we have immutable data types. You must be thinking, then what's the point? How can we have iterations in Elixir? But functional programming and Elixir has a much better way of doing loops, and that is by using recursion. And I'm going to talk more about recursion right in the next video. So what do you mean by recursion, and why is recursion so important? Let us try to answer these questions one by one. First, let us see what do you mean by recursion. In simple terms, whenever you perform the same task again and again, you can say that you are performing a recursion. That means you can see that we have one task, and this task is calling itself again and again. So you can say that we are in a state of recursion. Now if recursion is so simple, then what's the big deal with recursion? Let me try and explain this by taking you through a journey in time. You must have heard about the 7 wonders of the world. You have the Taj Mahal, you have the Great Wall of China, you have the Machu Picchu, and so on. But if we ask each one of us, what do you consider as the wonder of the world? The answer is going to vary. Let us see what's going to happen next. So these are some of the most smartest guys on the planet. So they are Warren Buffett and the great Charlie Munger. If you ask these guys, what do you think is one of the wonders of the world, then most possibly the answer would be compounding. Now let us see what's going to happen next. So there is one more really smart guy, and as you can imagine, this is the great Isaac Newton. If you ask Newton what would be one of the greatest wonders of the world, most probably he's going to say that it's gravity. So the point that I'm trying to make is, our perception changes from person to person. Now what happens if we ask this guy, that's me, what do I think about one of the greatest wonders of the world? And as you can guess, my answer would be recursion. Well, that's not exactly true. If you want a very honest answer from me, then I think that recursion plus mutation, that means recursive mutation, is one of the greatest wonders of this world. Sounds confusing, is it? Don't worry, now it's time for some explanation. Just consider us human beings. All of us have habits, right? And we tend to have the same habits over a long period of time. So can we say that our mind is in a state of recursion because we keep on repeating the same habit each and every day? You may argue that our habits can also change. Well, yes, they can change, and that's what I mean by mutation. But just try and consider, your habits don't change drastically overnight. Your habits may change over a long period of time. So you can also say that your change in habit is because of small mutations that take place each and every day. So maybe you can say that all of us are in a state of recursive mutation. Let's try and go a little larger. Let us try and think about the Earth itself. Now the Earth takes around 24 hours to come to the exact same point. So can we say that Earth is also in a state of recursion? Let us try and expand a little bit further. Now the Earth revolves around the Sun in an orbit. Now this, as you know, it takes around 12 months time. But what happens in every 4 years we have a leap year? That means we have a day extra. So can you say that even the Earth is in the state of recursive mutation? Now let us try and go even beyond our solar system. You must have also heard that the entire universe is in the state of expansion. Just go back 13.6 billion years ago when there was nothing, the Big Bang happened and the Earth, stars, Sun and the entire galaxies came into existence, and we are still expanding. How can this happen? Well, I can explain this by using a function which is written recursively. So this is our function. For now, you don't have to understand all of these things. You will understand these things in the future when you learn a little bit more about Elixir. Right now, let us try and see how the universe can expand from nothing. So if I say universe, and now this is the time for the Big Bang, and Big Bang is a function which takes no argument. Now let us see what's going to happen. Okay, so the Big Bang happened. After that, you can see that the size of universe is 0, 1, 2, 3, 4, and the size is constantly expanding. Now let me stop this, otherwise this will go for infinity. So what exactly happened? You can see that I have a function called as expand, and at the last the function is calling itself again, but this time we are just mutating the state. I have written state +1, but imagine that this is not +1. We are causing some kind of mutation, and that is what this is supposed to symbolize. Now this brings me to the last point. So as you can imagine, the very nature of the universe is recursive. That means all of the mathematics that we study for programming, that too is recursive in nature. And this concept of recursion comes naturally to functional programming. So now we get it. We had to take a really long journey in order to understand what is recursion and what's the big deal with it. Now let's see how to install Elixir. So what you can do is you can just go to this website, which is elixirlang.org, and you can simply click on install. And if you're using Windows, you can click on Windows. So from here you can download the installer, and as the instruction already says, you have to simply click on next, and finally finish. And if you are on a Mac, you can simply use brew to install Elixir. So if you are on a Mac, you can open up a terminal and you can type brew install and Elixir. And once you have installed Elixir, what I want you to do is just open up a terminal, or if you're using Windows, just open up your PowerShell. And here you can simply type Elixir and -v. So as you can see, I'm currently running Elixir 1.14.1. And if you're watching this video in the future, you may have some other version. But don't worry, all of the things which I teach you right now, they are going to work in future versions as well. The next thing for this video is, let us open up our Visual Studio Code and let us set up the Elixir plugin for this one. So just open up your extensions, and I want you to just search for Elixir. So this extension, which is for Elixir LS, so here you can see, and currently it has like 339,000 downloads. So just install this plugin, and this is what you really need to start working with Elixir inside VS Code. The first time you open up any Elixir file inside VS Code, you will get a small pop-up right over here, somewhere in the bottom right corner, and that pop-up will be saying that Elixir is building the PLT. So just let it happen. It's going to take some time, but let it run, and after the Elixir PLT is built, you can start working with your Elixir files inside VS Code. Now that we have Elixir installed, it's time to start learning more about Elixir. But first, before learning, we need to start unlearning, because a lot of concepts from the object-oriented world does not exist in the functional world. So that brings me to the very first statement. If I say A is equal to 1, And if I ask you, what do you think of it? Most probably you'll say that a is a variable and the value of 1 is being assigned to the variable of a. Well, you are right, but that's not what is happening inside the functional world. If I take you back to your high school days and just imagine that you are taking your very basic algebra classes. In that class, what we learned was a is equal to 1. That means a is your left hand side and 1 is your right hand side. So what maths is trying to say is your left hand side is equal to your right hand side. Your basic algebra does not say that 1 is being assigned to a. That concept does not exist. Now if we say that if the left hand side is equal to the right hand side, that means the right hand side should also be equal to the left hand side. So if I say that a is equal to 1, that means even this statement should hold true. And that is what happens in the world of Elixir as well. We will also have a demo of this shortly. Right now just keep in mind that equal to is not the assignment operator. This is the match operator. And what this operator does is that it simply matches your right hand side to your left hand side. And you are going to see this pattern a lot inside Elixir. This is also called as pattern matching, and this is a very powerful thing inside Elixir. Every time you see a statement like this, always remember that we are simply trying to match the right hand side with the left hand side. Now for the demo, let us open up our terminal. Elixir actually ships with an interactive shell or an REPL. So let us see how we can open it up and start using Elixir. We can enter inside the interactive shell by typing IEX. You can clear the terminal by typing clear. So here we can say that my a is equal to 1. Now if we say that is my 1 is equal to my a, and we get the output as true. You can also type as 1 is equal to a, and this simply gives back the value because 1 and a both hold the same value of 1. Let me clear this up. Let us try with one more experiment. Suppose I say that my name is Octallium. So in this case, if I say that is Octallium equal to my name, then we should get the answer of true. And yes, that's what it is. So just keep in mind that this is equal to is not assignment. We are simply trying to pattern match the right hand side to the left hand side. Let's try to learn a little bit more about pattern matching, and let us have a look at this example. Now the square brackets means that this is a list, and I would be covering more about list a little later in the series, but for now let us just go with the flow. For now I don't want you to concentrate on the syntax. I want you to concentrate just on the right hand side and the left hand side. Can you see that the pattern on the right is the same as the pattern on the left? We have two variables on the left hand side, we have two values on the right hand side. Here you can say that the value of 1 is now bound to the variable of a. Now the next variable is also a, and the value inside a is also 1, and that's what it is. So this is going to be true inside Elixir. For a quick demo, let me open up my terminal, and I'm already inside IEX. In case if you've forgotten how to go inside IEX, let me show you once again. For quitting IEX, just press Ctrl C twice and you can quit the IEX. And again, if you want to go inside, just type as IE and X. Again, let me clear it up. So here I can say that my list has two variables a, and the values are 1 and 1. So here it is, it's a perfect match. The right hand side is equal to the left hand side, so we get the values back. If I just say I want to see the value of a, and here it is, we get the value of a as 1. Now let us go back. Now can we guess what is going to happen this time? Now this time you can see that we have the values of A, and on the right we have the value of 1 and 2. Well, let us go to our IEX and see what's going to happen this time. So we have this A, and on the right we have 1 and 2. Let us see what's going to happen. Oh, we get an error, and if you watch closely we get an error saying that no match of the right hand side. And yes, it is not a match. The reason is the value of 1 is bound to the variable of A, and again the second value is A, but this time the value inside A is 1 and on the right the value is 2. So 2 is not equal to 1, and that's why the right hand side and the left hand side are not a match, and that's why we get an error. Let us go back. Now what happens if we write something like this? If we switch the second value from A to a new variable of B, can you guess what is going to happen? Well, let us go back and let us see what's going to happen this time. So here let me change the value from A to B, and let us see. Well, yes, it's a perfect match. So what's happening this time? The value of 1 is bound to the variable of A, and the value of 2 is bound to the variable of B. We can check it out. So if I say A, then we get the value of 1, and if I say B, we get the value of 2, and that's what it is right over here. Always try and think in terms of pattern matching. That means we always want to have the right hand side equal to our left hand side. So this is also called as pattern matching, and as I have said earlier, this is a very powerful pattern inside Elixir, and we would be using this pattern matching throughout this entire tutorial series. Till now we have seen a little bit about pattern matching inside Elixir, and we have been using our terminal, but we can do a much better job. And allow me to introduce to you LiveBook. So LiveBook is actually like the Jupyter notebooks for Elixir. But before I can show you LiveBook, you must have noticed that I have a different prompt and I have a couple of more colors inside my terminal. And this is because I'm using a little bit more fancier setup, but that's about it. Now let me go to LiveBook. So here it is. You can simply navigate to this website livebook.dev, and from here we can simply install LiveBook on our machine. So just click on install, and from here you can choose your Mac or Windows and download the setup. And after you have downloaded the setup, just install it as you would install any other program in your machine. Now I have already installed LiveBook, so let me just open it up. Here it is. So this is how it is. We can start a new notebook. We can simply click over here, new notebook, and that's it. We are good to go. Let us try the same code that we wrote inside our terminal. So here I can say is my a comma a equal to my 1 comma 1, and simply you can click over here, evaluate, and now we have the output right over here. Let us try with some other examples. So here I can say if my a is equal to 1, then is my 1 equal to a, and let us try to evaluate this cell, and yes, we get the output. Now what I have done, just for a reference, I have also included a couple of notebooks, and you can find all of those right over here. So this is the GitHub repo for this entire tutorial series, which is Octallium / it's right over here. You can go to Octallium and / Functional Programming with Elixir, and inside notebooks you can see that I have a couple of notebooks. Now in the future I may add a couple of more notebooks to this one, but at the time of recording we have 3 of those. So let us see how we can open these notebooks inside our LiveBook. So let me go back to my LiveBook, and let me just click on this icon on the left, and here I simply have to choose my path. So I have to go inside my GitHub, Octallium, Functional Programming with Elixir, notebooks, and let me choose the first one, and let me simply click on open. So this is the first LiveBook that you can find inside the repository, and as you can see, I have included a couple of text and also a couple of code blocks for your reference. So this is what we were trying to do last time. And if you see right over here, I have created some more examples. So if my name is equal to Octallium, then my Octallium should also be equal to name, and so on. So what you can do, maybe you can try to create a couple of more notebooks, and you can try to open up the notebooks which I have included inside the repo, and I'll catch you in the next video. Till now we have been trying to learn more about pattern matching, and let us continue with the same thing in this video as well. Now let us go back to our terminal and let me go inside IEX. So I can do that by simply typing IEX. Now again, please let me remind you that my prompt is looking different, and that is because I have customized the settings. I just wanted to have the prompt to be same as my logo. That's why I simply changed it, but that's about it. Now let me clear up the terminal, and here let us try to learn a little bit more about pattern matching. So again, let us create the same list A, and for the right hand side, let us say that we want to match with 1 and 2, and as you know, we are going to get a match error, and this is what we are getting. So again, let me try and refresh our memory what's happening. So what's happening is the value or the variable of A is bound to the value of 1, and on the next time what's happening is here we have A, but we are trying to match the value of 2 with A, and as you know, A is bound to 1, that's why we are getting match error. Now let's take a couple of minutes and let us try to understand why this is happening. This is happening because all of the data types inside Elixir are immutable. That means we can't randomly assign new values to an existing variable inside Elixir. Now you must be thinking that why does all of the types inside Elixir has to be immutable? The short answer is because for scalability, and we will come to this point in the next video, but for now let us try to understand what's happening behind the scenes. Now let me try to clear up the screen one more time, and this time let us say that we want our A and we want on the right to be 1. So this time what's happening is we have a match operator right over here, and the value of 1 is bound to the variable of A. But here comes a small caveat. So if I say A is equal to 2, so this time we don't have an error. But I just said that our data types are immutable inside Elixir. So what's happening? So whenever we have a variable on the left hand side of our match operator, at that times Elixir thinks that we want to bound the new value to the variable on the left. That's why we have the new value instead of A, which is 2. But if you don't want this behavior, then we can use a pin operator. So we can say the pin operator and A is equal to 3. So this time, as you can see, we get a match error, and the match error is saying that no match of right hand side value of 3, and this is because inside of A we have the value of 2, and on the left hand side we are trying to match a value of 3. That's why we get the match error. Now if we try to do this thing the other way around, and if we say that 3 is equal to A, so again this time we get an error saying that no match, and the right hand side value is 2. So yes, as you can see right over here, the value which is bound to A is 2, and that's why 3 is not equal to 2, and we get a match error. And on line number 4 we could rebound the new value of 2 to our variable of A, just because this variable is on the left hand side of the match operator. For now you don't have to worry too much about these things. As we progress and as we solve a couple of more examples, all of these things will get cleared very easily. Now coming to the next point, why do we need immutability inside Elixir? And my short answer was scalability. So let me try to explain why immutability helps in scalability. Since our data is not immutable, that means the data can be easily copied across various processes, and we don't have to worry if another resource, another thread or another process is changing or trying to mutate our data. This thing will get clear when we understand how code is executed inside Elixir and when we understand the actor model, and that's what we are going to do right in the next video. Let us try to understand how all of the code inside Elixir gets executed. Now all of the code gets executed in something which is called as an actor. So you can imagine your actor to be something like this box. Now this is an isolated box, and what happens is this box or this actor receives some kind of messages. Now these messages could be data, it could be instructions of what to do with the data and so on. After receiving these messages, your actor is going to process your messages and it is simply going to give you back some kind of a response. So in simple terms, you can imagine actor to be like an isolated computation unit. It gets something, it processes something, and it gives back something. Now what happens is these actors, they run inside something which is called as processes. And at a given time, we can have millions and millions of processes. This is where the data immutability comes into picture. We can have millions of copies of our data and they can be distributed across various actors, not only on our local machine, but we can have a global cluster of different servers and we can distribute our load horizontally across the globe. So these processes are not your operating system processes. You can imagine them to be like your virtual threads. So let's try to understand these processes one step at a time. We just saw the actor model, and these actors, they run inside your processes. For each process we have a separate ID which is called as PID, and I will show you the PID shortly in this video. The next part is we can communicate between these processes by message passing. And as we just said that since our data is immutable, we can create multiple copies and these copies can be sent to different processes. And since each actor gets its own copy of data, we don't have to worry if another actor is changing the state. Everything runs in isolation. The next part is each process has its own stack and heap allocation. So if we come from a compiled programming language such as C or C++, we have different memory allocation models. You can allocate your memory inside the stack or on the heap. And in case of Elixir, each process gets its own stack and heap allocation. So this way the garbage collection is very fast. We have to just garbage collect for a single process and our application remains responsive at the same time. Next, let us have a little bit more details about our actors. Every actor has its own mailbox. So every message that you pass to an independent process, they are collected inside this mailbox, and after that they are executed in a sequential order, and the order of execution is first in and first out. Next, these processes are very cheap to create. They require less than 3 KB of memory. So you can see it's very cheap and we can spawn millions of processes at a given time. And the last part to remember is we always communicate with message passing. Now let us go back to our terminal and let us check our PID over there. So PID stands for your process ID. So the first thing is, let us go inside our IEX. Let me clear up everything. Now this IEX is also running inside a separate process, and we can check the process ID by using the built-in function called as self. Now the next thing about Elixir is the parentheses are not mandatory. Self is a function, you can write the parentheses or you can leave them out. But these days the general convention is whenever you are writing code inside the code editor, at that time we prefer parentheses. But on the terminal, it's all up to you. I'm going to leave them out. And here we get the output. So the current process ID in which our IEX is running is right over here. And this is the address 0.107.0. So that's it for this one, and I will catch you in the next video. I think now we know enough of Elixir, and now it's time to write the all important Hello World program. So let us get started. Let me open up my terminal, and here let me create a folder by the name of Functional Programming with Elixir. Now let me go inside of this folder, and here let me create one more directory for scripts. Now let me go inside my scripts directory, and here let me create one more file by the name of hello.exs. Now Elixir has two file extensions. This .s that you can see right over here. This means that we want to create a script file, and whenever we want to create a compiled file, that time we simply write as .ex. We will see more about the .ex extension when we create our first project by using the mix tool. But right now just keep in mind that whenever we want to create a script, at that time we simply add a s. Now there are a lot of times when you need extra files. For example, you need a file to just seed your database, or if you want a file just for testing. These files are not meant to go into production, they are just meant for your development. Now let me go ahead and create this file, and let us open up this file inside our code editor. Now my code editor is complaining that no mix file found, so right now just ignore this, and when we create a project by using mix, it will go away. Let me collapse my sidebar. So the first thing that you should keep in mind that all of the code inside Elixir stays inside its modules. So let's create a module, and for creating module we simply have to say that we want to define a module, and let us name the module as hello. And next, for Elixir we don't have curly brackets, instead we have the do and end blocks. So what we have done till now is we have simply defined a module, and all of the code will go inside this module. As a general convention, the module name and the file name should be same. It's not required, but just as in community convention, they should be equal. For example, let me open up my sidebar. Here you can see that we have named the file as hello, and we have also named the module as hello. Let me collapse my sidebar, and inside of this module, let us create our first function. And you can create functions by using the keyword called as def, and let us call our function as world. Now this function will not accept anything, so you can keep your blank parentheses, or you can leave them out completely. That means this is a function which does not accept any parameter. Then again we need to create our do and end blocks, and here we can say that from our input output we simply want to put something to our output, and here we simply want to display the message of hello Elixir. Now always use the double quotes for defining your strings. Single quotes are meant for characters, but right now since we want a string, that's why we have put double quotes. Now let us save this program and let us see how we can run this program. Let me adjust the screen. We can run this file in a couple of different ways. So let us see the first method. Here we can simply say that, hey Elixir, I simply want you to run the file which is called as hello.exs. And you can see that Elixir actually ran our file, but we don't have any output. And we don't have an output because we have not called the function of world. So let us do that right over here. Let me take my terminal slightly down, and here what we can do is, here we can say that from our module of hello, I want to call the function of world. Let us save the file, and now let us go to our terminal and let us try to run the same command one more time, and this time we get the output of hello Elixir. So you can use this method whenever we want to run a script file. But Elixir is actually a compiled language, so let us see how we can actually compile this file. Now again, please keep this in mind that whenever we want to have a compiled file, that time the file extension should be .ex. But right now let me show you how we can compile and run this script. So let me clear up my terminal, and here instead of writing Elixir, we can say that Elixir compiler by adding a C right over here. So this stands for Elixir compiler. So now Elixir is actually going to compile this file and then it will run for us. So let me open up the sidebar. Here you can see that we have a single file hello.exs, and this one is created by our Visual Studio Code. Now let us compile the file and let us see what happens. So as you can see in the sidebar, Elixir actually compiled and we have a new file called as elixir.hello.beam. Now remember that Elixir runs on the Beam virtual machine, and this is the compiled file for our Elixir code. But normally we don't compile and run the Elixir files like this. we would use the mix tool, and we will learn more about the mix tool as we progress in the tutorials. But right now, let us go with the flow. Now let me collapse my sidebar. We can also run this file inside our interactive shell. So let me show you how we can do that. Let us go inside our interactive shell and let me clear up everything. Now here we can say that we want to compile the file of hello.exs, and that's it. Now we are getting a warning saying that redefining module hello, and that's because just a couple of seconds back we actually compiled this file, and that file is currently inside our memory. But right now we can simply ignore all of these things. Next, your IEX actually ran the file, and here we can see we have the output of hello Elixir. Now let me clear up the screen one more time, and let us see how we can also manually call the function. So here we can say that I want you to go to the module of hello, and from there I want you to go to the function of world. Now remember that parentheses are optional inside Elixir, and since our function of world does not accept any parameters, I can have my blank parentheses or I can simply leave them out. And here you can see that we have an output of hello Elixir, and after this we also have a message saying as OK. Now OK symbolizes a data type which is called as atom. We will learn more about the data types in the next video, but right now let us go with the flow. Now again let me close my terminal, and this time let us make the function accept some kind of a parameter. So here we can say that we want the function of world to accept a parameter, and we want to name the parameter as name. Next we can use our string interpolation. So here let me take out Elixir, and here we need to put the hash sign, and then we need to put the curly brackets, and inside the curly brackets I can simply use our parameter of name. And also let me take out this line, this is not required. So let us open up our terminal, and we have our IEX running. Now since we changed the file, let us recompile the module, and we can do that by typing R. Now R stands for recompile, and we simply want to recompile our module of hello, and that's it. We have redefined the module. Let me clear it up, and here we can say that hello.world, and now let us pass a parameter called as Octallium, and we have the output of hello Octallium. Now remember that the parentheses are optional, so we can also write something like this. Let me take out the parentheses and let me give a space right between over here. So as you can see, this code is also valid, and we get the exact same output. Well, that's it for this video, and we will see the different data types in Elixir right from the next one. Let us try to learn more about the different data types in Elixir. The first thing which I wanted to remind you is all of the data types in Elixir are immutable. In common terms, what I mean to say is all of the data types inside Elixir are constants. Now with this concept in mind, let us go ahead and let us try to study the first data type, and that data type is called as an atom. An atom in Elixir looks something like this. So we have a colon symbol right over here, and after the colon we have the name of the atom. And in case there is some space inside the name of the atom, then we can write an atom like this. So again the syntax goes like this. Your atom will always start with a colon, and then we have the name of the atom. And in this case, since we have a space inside the name of our atom, we are using double quotes, and inside the double quotes we have the name of the atom. Now this was just the syntax of an atom, but now let us go ahead and let us try to understand what's an atom all about. So let's consider this scenario. So we have a symbol or a logo like this. Can you tell me what this logo symbolizes? Now this logo is of a very popular brand, and that brand is Nike. So what's happening in this case? This symbol is synonymous with the name of Nike. If I show you the symbol or if I show you the name, both of these values point to the exact same thing. So this is just a pseudo code, and this is not a valid Elixir syntax, but let us understand the concept of an atom. So what's happening right over here is we have a variable, and the name of the variable is Nike, and the value assigned to this variable is also Nike. So in short, the value and the name are the same, and this is what an atom represents. In an atom, the name and the value is always same, and we can represent this in terms of atom like this. So we have an atom for Nike. Let us open up our IEX and we can start playing right over there. So this is my terminal. Let me go inside my IEX and let me clear out the screen. So let us create the same atom for Nike. So we can say Nike. This is what an atom is all about. Suppose we had a very long name that had spaces in between. So we can say something like this, the and Nike. So this is also a valid atom. And you will notice that our atom always starts with a colon. Now what we can do is, let us go to our LiveBook and there we can create a couple of more examples of atom. So this is our LiveBook and let us create a new notebook. Let me give the title as data types, and this section is all about our atom. In Elixir you will see atoms everywhere. Atoms are very heavily used for pattern matching. Now suppose you are working on some kind of an application and you want to return an error message. So that time what we can do is we can simply create an atom called as error. So we can say something like this, error, and let us click on evaluate. So here it is, we have created an atom which is called as error. Next, let me show you a very practical use of this kind of an atom. So let's take the exact same example. Suppose we are working on an application and we have an error where we are not able to find a file. So at that time, it's very common to return back a tuple, and the tuple is represented by this curly strings. Now I will cover tuples a little later in the series, but right now let's go with the flow. And inside the tuple, we can say that the first element is an error. So there is some error in that operation, and then we can describe the reason for the error. So we can say, for example, file not found. And this kind of pattern is very common inside Elixir. Normally we will have a 2-element tuple or a 3-element tuple, and regularly you will see that we simply pattern match on this tuple. So what we can do is, on the left hand side, we can again pattern match with this tuple. So let me create a new tuple right over here. And the first element is an error. The second element we can call it as a reason. Now again, what's happening over here is we are simply using our pattern matching. I want you to go back to the concept of your left hand side is equal to your right hand side. So on the right hand side we have a tuple, and on the left hand side we have a tuple. Next, what is happening is on the right we have a string called as file not found, and on the left we have a variable. Oh, let me get the spelling right. This has to be reason. So what's happening is, since we have a variable on the left hand side, this value of file not found is being bound to our variable of reason. So let us click on re-evaluate and let us see what's happening, and we get our tuple back, error, file not found. Let us split this into different code blocks. So let me create a code block right over here, and let me take this code out from here and let me paste it right over here. Again, let me click on re-evaluate, and here also we can evaluate. Now what we can do is, since we are using pattern matching, we can extract the value of file not found. And I just said that this value of file not found is bound to our variable of reason, and we can check out the value by simply typing our reason, and let us click on re-evaluate, and here we get the value back, file not found. Now this pattern is very common in Elixir. So let us have a look at one more example, and suppose this time we have a successful operation. For example, if we are working on some kind of an web application and we get back a status 200 message, so at that time what we can do is we can pattern match on OK, and then we can have a message, and here we can pass our OK and we can say status 200 OK, and then we can see the contents of our message. Now let us click on evaluate, and as you can see we get the value of message back. So again the same thing is happening over here. We simply have to pattern match the right hand side along with the left hand side. OK is matching with the OK right over here, and this string is being bound to our variable of message, and that's what we are calling on the next line right over here. Well, this was all about atoms, and in the next video we will start with strings inside Elixir. The next data type in our series is going to be the string, and strings in Elixir are represented by double quotes. So this is going to be a valid string for Elixir. We have the double quotes, and inside the double quotes we have the string. Now instead of the double quotes, if you use a single quote, then that would mean a character list, and a character list is different from a string inside Elixir. Now let us go and play a little bit with strings inside our IEX. Now let us go inside our IEX and let me clear up the screen. And as I just said, we can create a string by using our double quotes. So let me write Octallium. So this is going to be a valid string inside Elixir. Now what happens, the IEX also provides us with a lot of convenience functions for checking different data types. And one such function for displaying the information is called as I. So let us call I and let us pass the variable of Octallium and let us see what kind of output we are getting. So we can see that the term is Octallium and the data type is a binary string. So what happens inside Elixir is your strings are actually saved as a collection of bytes. That's why it is saying that the data type is a binary string. Next, the size of our string is 9 bytes. And the next thing that you can see is in Elixir, a string is actually a UTF-8 encoded binary. Now I just said that your strings are saved as a collection of bytes, and this is how it actually looks inside your memory. And as you must have noticed, it starts with double angle brackets and it also ends with the double angle brackets. Now inside of this collection you can see that we have the individual integer representation of each of the characters inside our string. For example, the integer of 79 denotes a O, 99 denotes a C, and so on. Next, we can also see a couple of protocols that are implemented for the type of a string. Now protocols are a slightly advanced topic and we will not be covering protocols in this tutorial. But for now, let us go ahead and let us see what else we can do with the strings. Now let us have a look at a little bit of magic of pattern matching with our strings. Now strings is just a collection of our bytes. And what we can do is we can use our pattern matching to extract individual code points from our string. So let me clear up the screen. And here what we can do is we can simply match for an O for Octallium. So we can say that our first character should be O and the next one we can collect in a different variable called as rest is equal to Octallium. And let us see what happens next. Now let us see the contents of the variable of rest, and here we can see that the rest variable contains all of the alphabets after O. So what's happening on this line right over here? So again the same thing goes, your left hand side should be equal to your right hand side. On the right hand side we have a capital O and that is being pattern matched right over here. And next we have a string concatenation operator. And we are saying that we want to collect all of the different code points after O inside a variable called as rest. So what happens, all of the other characters starting from C all the way to M, these characters get bound to our variable of rest, and that's what we are checking on line number 6. Let us have a look at one more example. Suppose we again want to see the information for a new string called as ABC. Now again the parentheses are optional, so even if I take out this parenthesis, still the code should work. And here we get the output, and here we can see that the raw representation of A, B and C is right over here. Now what's happening is 97 simply denotes the code point for our character of A, and we can check that out by using a different syntax. So we can put a question mark followed by A. So this gives us the code point representation for A, and here we can see that it's 97, and that's what we have right over here. Now suppose we want to see the code point for B. So B is going to be 98, and for C it's going to be 99, and so on. Now with all of these points in our mind, let us go back to our LiveBook and let's start playing a little bit more with our strings. So here let us create a new section. So I want to go on blog and create a new section, and this section is all about your strings. So let us create the same string right over here. So we can say we want to create a variable called as name, and let us assign the value of Octallium to this one. Next, let us just print out the value of name and let us see what output we are getting. And as expected, we are getting our string back. Next, we can also check if the given data is of the type of string or not. So for that, we can use an inbuilt function called as isBinary. So remember, your strings are represented as a collection of your raw code points or a collection of your bytes. So we can use this function of isBinary and let us pass the variable of name and let us try to evaluate, and we get the answer as true. So yes, this is a binary. That means this is a string. Next, let us see how we can add two strings together. So let me create a new code block and let us create a new variable called as message. And here we can create a message saying that hello. And for adding or for concatenating, we have to use this double angle brackets, and then let us pass our variable of name. So again, just to help you remember, here we have the angle brackets, and if you go back to our terminal, and here we can see the raw representation. Here also we have the angle brackets. The only difference is for the representation we use the double angle brackets, and for string concatenation we use the single angle bracket. So let us see the output of this one. So let us try to evaluate, and here we have the message of hello Octallium. Next, we can use our pattern matching and let us try to extract values from the string. So let's create a new code block, and here again we can pattern match. So we can say that the first couple of characters should be hello, and after hello I want to collect the remaining in a new variable called as name. And on the right hand side we have to simply pass the message. So remember, message is hello Octallium. So hello and this space right over here, this is going to be pattern matching right over here, and the name of Octallium would be bound to our variable of name. Next, we can also check out the contents of the variable of name. So let us write it over here and let us try to evaluate, and here we get the name back as Octallium. Now there is one more way of pattern matching with our strings, and this method is by pattern matching on the raw representation. So let's see how we can do that. So let us create a new code block. Now remember that the raw string representation is done by our double angle brackets, and here let us try to pattern match. So here we can say that we want to pattern match the first character or the first code point in a new variable, and let us call that variable as head. Next, what we want to do is we simply want to collect all of the remaining code points in a new variable, and we can call that variable as rest. Now since we are using the raw string representation, we also need to tell to Elixir in which format do we want to collect all of the rest code points. So here we can say that the type of rest would be binary, and on the right hand side we simply have to pattern match with name. And next, let us see what is inside our variable of head, and let us try to evaluate this cell. So what's happening right now is instead of getting a string back, we actually get the code point back. And if we refer back to our terminal, as we can see right over here, so this 97 actually denotes our code point of A. So that's what is happening right over here. So in this case, 79 actually denotes the code point for our O, and we can check it out in a new block. So let us create a new block right over here, and here we can say that is my head is equal to the code point of O, and let us try to evaluate and see what answer we are getting. So yes, the answer is true. So if you are feeling a little bit confused, so let us go back to our terminal. Let me clear all of these things, and let us check the code point for our character of O, and we get the integer representation as 79, and that's what we are checking right over here. So the value inside head is 79, and that's what we are checking in this line. And since the character value of O is also 79, that's why this expression is evaluating to a true. So you can see that pattern matching is very powerful inside Elixir, and we use pattern matching practically everywhere inside Elixir. Let us take the same example. So let me copy from here and let us create a new code block and let me paste it right over here. And here, instead of using this variable of head, let us pattern match on O and let us see if we can get the rest back, and let us try to evaluate this expression and we get the right answer back. So we get all of the characters from C to M. Now it's not mandatory to just pattern match on a single character. We can pattern match on multiple characters. So let me copy this one. Let us create a new code block and let me paste it over here. And this time we can use two characters. So let us pattern match on O and C. And next let us check the contents of rest and let us try to evaluate this cell. And as you can see, we get the right output. So you can see that pattern matching is really very powerful inside Elixir. Next, you can be also very specific while pattern matching with strings. You can actually specify the number of strings that you want to collect. So let me show you an example right over here. Let us create a new code block and let me copy this thing right over here. Now instead of saying O and C, what we can do is we can say that we want to create a variable called as head, and inside this variable we want to collect the first two binaries. So here we can say that we want to collect the binary and the binary size should be for 2 characters. Next, let us check the output of our head and let us try to evaluate this one. And as you can see, we get the characters of O and C back. Well, this was all about strings inside Elixir. Now don't worry if you don't get this pattern matching with binaries and all of these things. I just wanted to show you all of the different possibilities by using pattern matching inside Elixir. The next data type is our Charlist or our character list. And as I have already explained, the character list is created by using single quotes. So let us create a variable called as characters and let us assign the value of Octallium. Now as you can see, I'm using single quotes right over here and we get back the value of Octallium. Now let us do one thing. Let me copy this and let us go to our terminal, and inside my IEX I can check for the information. So I can use the inbuilt function of I and let me paste the character string right over here and let us see what kind of output we are getting. So this time if you see, the data type is actually a list. Last time when we were studying about strings, the data type was a binary string, but this is a collection of characters inside a list. And if you want to see the raw representation, so here it is. Now please note that as this is a list, we have square brackets at the start and also at the end. And as you can see, each of the characters are also represented by their integer values. So again the same thing goes. 79 represents O, then the value for C is 99, then for T it is 116 and so on. So let us go back to our LiveBook. Next, let us see how we can add two character lists together. So let me add a new block and here let me create a new character string and let me say hello. And for adding or concatenating two lists together, we have to use the double plus symbol and let me pass the characters value right over here and let us try to evaluate this cell, and here we get the new value back as hello Octallium. Just as a reminder, for strings we were using the angle brackets, but since this is a list, that's why we are using the double plus symbol. Next, we can also use an inbuilt function to check if the given characters are indeed a character list or not. So again, let me add a code block and here we can use the inbuilt function of is list and let us pass our characters inside of this one and let us try to evaluate. So yes, we get the answer as true. And the last point is we can always check the code point. So we can use a question mark and then we can use a character. So the code point value of A would be 97, and if you check for O it would be 79 and so on. So this was all about characters. The next type that we are going to see is called as the process. So let me take everything up and here let us add a block, and we want to add a section for process, and let us add a code block right over here. Now if you refer to my earlier videos, so this was the video about processes in which I explained that all of the code is executed inside processes. So these processes are also a valid type inside Elixir, and we can check the current process in which our LiveBook is running. So let's create a variable called as myPID. So the PID stands for the process ID, and we can use the inbuilt function of self, and let us check the output of myPID after this one, and let us see what kind of output we are getting. So we get the output as PID is 144. Now if you go back to our terminal, and here let us check the process in which our IEX is running. So let me call the function of self, and this time we can see that we have a different PID number. The process ID for our IEX is 107, but if we go back to our LiveBook, we can see that our LiveBook is running inside the process number 144. Now processes and concurrency in Elixir is a very huge topic, and it requires its own dedicated tutorials. But for this course, let us go ahead and let us see the next type. Let us add a new section right over here. So I want to add a new section, and this section is all about our list. Let me take this thing a little up. So the number one thing that you need to understand about list is that the list inside Elixir are actually linked list, and they are not your regular list. So if you try to do operations like indexing, it is not going to work. And just to be precise, the list inside Elixir are actually singly linked list. So let us see how we can work with list inside Elixir. Let us create a new code block right over here, and let us create a list. So this is our list, and for a list we can see that we have the square brackets at the beginning and at the end, and let us try to evaluate this cell, and we get the list back. Now again, let me try and repeat that this list is not your regular array or not your regular list. This is a singly linked list. Let's do one small experiment, and let us try indexing on this list. So let us create a new code block, and suppose if I try to see the element at the 0th index. Now let us see what happens, and as you can see, we get an error. And we get this error because this list is actually a linked list and not your regular list. Now the reason that we have linked lists inside Elixir is because linked lists are recursive in nature. Your regular arrays or your regular list, they are not recursive, and they have to be saved continuous in your memory. But then how do we work with lists inside Elixir? Now there are a lot of mechanisms. First and the obvious one is by using recursive functions, or we can also use a lot of inbuilt modules. So let me show you one module. Let me add a code block right over here, and let us take everything up. Now we can use the module of enum, and we can say that enum, and we can use the inbuilt function at, and let's pass our list, and let us call the index as 0, and let us see what kind of output we are getting. And here we can see that we get the output as A. So what we are doing is enum is actually an inbuilt module inside Elixir, and at is a function which is defined inside the enum module, and here we are simply passing the arguments for the function. Let us go back to our IEX, and let me clear up everything. Let me make some space from the top, and here if I write enum dot, and if I press tab, here we can see that we have a lot of inbuilt functions for the enum module. And the function that we use is right over here at. Now this /2 actually means the arity. Now arity is nothing, it's just the number of arguments that your function can accept. In Elixir, we can actually overload our functions by using different parameters. So for example, you can see right over here, we have a function called as any, and for this function we have two types. The first type is right over here. So this function takes only one argument, that's why the arity is 1. And here we have the same function any, but this time it takes 2 arguments. So that's why the arity is shown as 2. Now let me clear up all of those things. Now let me show you one more helper function inside Elixir, and the name of the function is h. So h stands for your helper. Again, if you want, you can use the parentheses or you can leave them out. And here we need to specify which module or which function do we want help for. So what this helper function does is it simply prints out the documentation for that module or for that function. So here we need to specify that we want to see the documentation for the module of enum, and from enum we want to see the documentation of the function of add, and here we get the documentation back. The first line that you can see right over here, this is all about your function definition, and you can see that the first parameter is actually a enumerable, the second one is the index, and this function also accepts an optional argument by the name of default, and the default value for this parameter is nil. These two backslashes symbolize that this argument of default is an optional argument, and in case if this argument is not specified, then the default value would be simply nil. Next we can see that we have a couple of examples right over here. So you can see that the helper function is very useful, and I often use this function for reading the documentation inside my terminal. Now let us go back to our LiveBook, and here let us play a little bit more with pattern matching and with our list. So let me create a new code block. Now if you refer our list, so our list has 3 different elements, and we can use pattern matching to extract all of these elements. So let me show you how we can do that. So here let me create a couple of different variables. The first one should be called as first, second, third. You can call this parameters anything that you want, and on the right I simply want to pattern match on the list. So what's going to happen is the same old thing, the left hand side should be equal to the right hand side. So the first thing is, since this is a list, on the left hand side we do have a list, and we are simply trying to pattern match on the different elements. So this A would be bound to our variable of first. For the second, your B would be bound, and C would be bound to third. Let us check out the data inside second. So let me call second right over here, and let me take it up, and also let us try to evaluate this cell, and we get the value back as B. Now what happens if you don't want all of the variables and you simply want to ignore a couple of them? At that time we can simply use an underscore to ignore the values. So suppose I don't want the values of first and second, then we can do like this. So we can create a list. Since I want to ignore the first value, I can use an underscore. I also want to ignore the second value, so let me put one more underscore. The next I want to collect the third value, so let me create a variable called as third, and let us assign a list right over here. So our list is A, B and C. Now let us check the value inside third, and let us try to evaluate, and we get the value as C back. So what happened is, since we have an underscore, that's why the value of A is simply ignored. The same thing happens with B as well, and finally the value of C gets bound to our variable of third. Next, let me show you a couple of convenience functions for working with our list. So the first function is also called as head. So let me show you what I mean. So the head function simply takes the first value and returns it back. So if we call the inbuilt function of head, and let us pass our list to it, and let us try to evaluate, and as you can see we get the value of A back. Now similar to head, we also have another function which is called as tail. So let me create a new code block, and the function is called as TNL. Now what a tail function is going to do is, it is simply going to ignore the head value and it will return back all of the remaining values. So let me pass the variable of list to this one, and let us try to evaluate the cell, and we get back the values of B and C. There is also a shortcut method for doing this, so let me show you how we can do that. And this time we can simply pattern match on our list. So here let us create a list, and I want to pattern match the first value inside a new variable called as head, H for head, and then let me use a cons operator, and then I can say that I want to collect all of the remaining values in a new variable called as tail, and let me assign the value of list to this one. Next, let us check the value inside our head, and let us try to evaluate this cell, and as expected we get A back. Now this pipe operator is also known as cons operator for working with our linked list. Next, let us also check the value inside T. So let me create a new code block, and let me call the variable of T, and as you can see we simply get back the remaining values inside our list. The next data type is the tuple, and we have already seen a couple of examples of tuple, but let me show you once again. So the tuple is created by using the curly brackets. So you can say we want to create a 2-element tuple, and we can say that the values should be 1 and 2. So these curly brackets are used for creating an tuple. Now tuples are very similar to your arrays, and all of the data inside the tuple is saved continuously inside the memory. And it's very common to have 2 or 3 element kind of a tuple. But if you want to save a large number of elements, then it is recommended to go with the list. Now here also we can do a simple pattern match. So on the left, let us create one more tuple. We can say A and B, and let us check the value of A, and let us try to evaluate, and we get the value back as 1. This time let us create a 3-element tuple. So in the future, whenever you are learning about web development using Phoenix, that time you will see that it's very common to have 3 elements or maximum 4-element tuple. And a very common pattern would be something like this. So the first element would be a tuple called as message. The second element would be the actual message that we want to send back, and the third element would normally be the state of your server. And let us create a tuple on the right. So the first element should be reply, message could be a string, Octallium found, and for the state we can pass a simple list of all of the friends of Octallium. So we can say Octallium, Lewis and Chico. Next, let us try and print out the message, and let us try to evaluate. Let's also check the state of our server. So we can say state, and let us try to re-evaluate, and we get the right list back. So as you can see, tuples are a very convenient data structure inside Elixir, but normally don't use more than 3 or 4 elements inside a tuple. The next data type that we are going to see is also called as the keyword list. So let me show you how a keyword list looks inside Elixir. So we can create a variable called as data. Now keyword list is actually a list, but inside the list we have the key and the value pairs. So we can say that A is 1, so A is your key, 1 is the value. Then we can say B and 2, and let us try to evaluate, and we get back our keyword list. Now what happens inside the keyword list is your key would normally be an atom, but if you remember, we write the atom as colon first and then the name of the atom. And in fact, this key value pair is actually saved as a tuple. So let me show you how it is saved as a tuple. So here let me create a list, and inside the first element, that is the key, is always saved as an atom. So I can say A, and the second element is the value, so it would be 1. And let us try and pattern match on a very simple keyword list. So we can say A and 1. So as you can see over here, A and colon, this is just a convenience feature, but while saving inside the keyword list, it is actually saved as an atom, and this key value pair is converted into a tuple, which we can see right over here. Now let us try to evaluate, and we get the same answer back. That means we have a match between the right hand side and the left hand side. For accessing the different values inside the keyword list, we can use the inbuilt module. So let us go back to our terminal, and let me write keyword dot, and let me press a tab. And as you can see, we have a lot of convenience features for working with our keywords. Let's go back to the LiveBook, and let me show you how to fetch values from a given key. So for example, I can say that I want to access my keyword list of data, and then I want to access the key of A, and let us try to evaluate, and we get back the data as 1. Well, that's it for this one, and we will learn more about maps and struct right in the next one. The next data structure that we are going to study is called as a map. So let me create a variable called as myMap. Now in the last video we saw how to create a tuple, and for creating a tuple we normally use the curly brackets, and for creating a map we simply add a % symbol. So maps are more like your dictionaries in your Python. These maps are also your key and value kind of a data structure, but maps offer a lot of features as compared to your tuple or your keyword list. Inside maps, we can use different data types for our keys, but right now let us see how we can use an atom for our key. So we can simply say A colon and 1, then let us add one more element B, and let us add one more C and 3. So this is how you can create a map. And what happens is when you use a tuple for your key, at that time we can use the dot notation. I will show you shortly what I mean by the dot notation, but right now let us see how the map looks like, and we get the map back. Next, we can use our pattern matching to extract values. So here let me create a map, and inside the map we can pattern match on the key of A, and let us collect the value inside a variable called as first. Next, we can pattern match with B, and let us collect the value inside second. And for the last one, we can use the variable of third, and let us pattern match with the variable of my map, and let us see the value inside the variable of first, and let us try to evaluate, and we get the right answer back. Well, maps are a very convenient data structure. Suppose if you want to extract only the second value, you don't have to use the entire map. Instead, we can do something like this. So let me just show you. Let us create a map, and let us say that we simply want to pattern match on the key of B, and let us collect the value inside second, and let us pattern match with our map of my map, and let us see the value inside second, and as you can see we get the right answer back. So it's not mandatory to create the entire map to pattern match. Instead, we can create a shorter map with just the required elements. So here we are simply pattern matching on the key of B, and we are collecting the value inside the variable of second. The next thing is, since we are using atoms for our keys, we can use our dot notation to access the values. So let us create a code block, and we can say my map dot A, and let us try to evaluate, and we get the answer back. But if we have a different data type, for example, if we have a string for the key values, then you can't use the dot notation. Let us create one more map, and let me call it as map2, and let us create our map right over here. Now if you plan to use a string as your key, then we need to write them inside quotes because they are strings. And since we are using a data type which is not an atom for the key, we need to use the arrow notation, and here we can assign the value as 1. Next, let us create one more key for B. Again, remember, since the key is not an atom, we are using the arrow brackets. Here we can assign the value of 2, and we can create the last one C, and let us assign the value of 3, and let us evaluate the cell, and we get our map back. Next, we can use the same pattern matching techniques. So for example, if we want to extract the value of C, then let us create a map, and since this time the keys are strings, let us pattern match right over here, and let's say that we want to collect the value inside a variable called as C, and let us pattern match with our map number 2, and let us see the value inside the variable of C, and we get the right value back. Elixir provides a lot of inbuilt features for working with our maps. So if we go back to our terminal, and if I enter map and dot the tab, we can see that we have a lot of different features. For example, if you want to fetch something, or if you want to create a new map, or if you want to replace some values, or if you want to update some values, so we can do a lot of things with the map. But for now, let me show you a very easy method of updating our map. So let us create a new code block, and suppose we want to update the value of C from 3 to 4. Then we can say that we want to update the value of our map, and the variable name is map2, and then we can use the pipe operator, and then we can say that we want to update the value of C from 3 to 4, and let us bind the value of this back to our variable of map of 2, and let us try to evaluate and see what kind of output we are getting. And as you can see, we have updated the value of C. Now we are using this arrow notation because we have strings for our key values. But in case if we have atoms, then we can simply use the colons. So let me show you. So we have another map by the name of my map, and then we can say that we want to update my map, and this time we want to update the value of C. And since C is just an atom, we can use the regular notation and we can say that we want to update the value to 4. Let us try to evaluate and we get the updated value back. Well, that's it for this video. This was a very short introduction to maps, and we will learn much more how to work with maps as we progress in the tutorials. The next video is all about structs in Elixir. The next data type is the struct, and if you come from a compiled programming language such as C or Go, you must have worked with structs. And now let us see how we can create a structure inside Elixir. Now for creating a structure, we need to create modules, because by default the structure will take the name of the module. Suppose we want to define a structure for the user, then we can create a module. So we can say create module user, and then inside the module we can use another macro, and the name of the macro is called as def struct. Now all of these things that we can see over here, def module, def structure, these are all macros. That means they create a code from a given code. But right now we don't have to learn more about macros. Let us see how we can define a struct. So what we have defined is we have created a module called as user, and then we are using another macro called as def struct. Now here we need to specify the different fields for our struct, and these fields have to be specified in the format of your key and value pairs. Now here again we can use the bracket notation if you want, or if you don't want, you can leave it out. And here let us see how we can specify the fields. So we can say that the first field should be username, the second one should be an email. Now this is one way of specifying your fields, but if you want to initialize with some values, at that time we can also pass the key and value pairs. So for example, if you want to say that while initializing we want the age to be nil, and for the email we can say that we want to have a blank string, and for the username also we can say that while initializing we simply want to have a blank string. So what we have done is we have simply converted from a list of atoms to a list of key value pairs, and all of these parameters are going to become the fields for the user struct. Next, let us see how we can create and initialize a struct. So let me add a code block. Now working with struct is very similar to working with a map. For creating a map, we used to use our % symbol and the brackets, and for the struct is very similar, just that we have to use the name of the struct. So this is how we define a struct. Inside, let us specify the different fields. So we can say the value for the username would be Octallium. Suppose my age is 14 years and my email can be octobot@sample.com, and let us try and evaluate. So what we have done is we have essentially created a struct, and this is how we can initialize a struct. Structs behave very similar to our maps, and we can use the same pattern matching techniques on our struct as well. So for example, let us assign this one to a variable called as user1, and let us evaluate. Next, let us create one more code block, and suppose we want to extract the username, then we can simply create your regular map, and here we can say that the field name would be username, and let us create a variable name, and let us pattern match on the variable of user1. Next, let us see the value inside username, and let us try to evaluate the block. And as you can see, we are getting the right answer back. So what we did was this user1, this is a struct, but structs behave very similar to maps, and that's why we can use our map notation for pattern matching. We can use the same technique for updating values inside a struct as well. So for example, if you want to update the age, so you can say that the map of my user1, and inside this I want to update the age to suppose 21, and let us rebind the value this back to user1, and let us try and evaluate. and as we can see, we get the updated age back. Well, that's it for this one. So what we have done is, till now we just had a very short introduction to the different data types in Elixir. But if you're not feeling confident, don't worry. As we progress and as we have more practice, you will start feeling much more confident. Till now we have seen a couple of different data types inside Elixir. Now if you're not feeling confident, don't worry, we will have more practice as we progress with the tutorials. But right now let us go with the flow. I simply wanted to introduce you a couple of topics before we can dive much deeper into them. The next topic is all about your flow control. Inside Elixir, for creating loops, we would normally use recursion. But other than recursion, we have a couple of different mechanisms for our flow control. So let's have a look at the first flow control mechanism called as a case. Let us create a simple list. So we can say that the list is going to be 1, 2, and 3. Now what we can do is we can create a case statement. So this case statement acts more like your switch statement. So let me create a statement and then I can show you how it works. So here we can say that we want to create a case, and let me put the end block. Now here we can say that we simply want to fetch the second element from our list. So remember, the second element from our list would be 3. So this is at index number 0, 1, and 2. So we can say that we want to fetch from the list the second element, and after that, depending on the result of this statement, we can pattern match on a couple of different cases. So let us create the first case inside of this one. So here we can say that in case this statement evaluates to a 1, at that time we simply want to return back a string, and the string would be this one print. Next, we can also create multiple cases. So in case we get the answer as 3 back, at that time we simply want to return 3 is a match. And the next one is a catch-all case, and for that we can say that we want to use an underscore. That means we are not interested in the value, but in case we don't have a match for the return of this statement, at that time we simply want to return a string called as catch-all. Now let us try and evaluate this one, and as you can see, we get the answer as 3 is a match. So let us try and reiterate what happened. So we have created a case statement and we simply want to pattern match on the result of this expression right over here. So this statement evaluates to a 3, and since we get a match, that's why we get the return as 3 is a match. We can use this case statement to pattern match on almost anything. So for example, suppose we have a structure. So let us create a module. So we can say we want to create a module for post, and inside this let us create a structure and let us create the different fields. Suppose we want to have a field for the ID and we want to initialize to nil, and then we want one more field for the title. Let us initialize to a blank string. The next one could be for the description, and we can again assign it to a blank string. The last one could be for an author. Again, let us assign a blank string. So we have created a struct. Next, let us create a post. So we can say that we want to create a post 1 and we want to have a post. Suppose the ID is 1. The title could be title number 1. The next we want the author. Suppose the author is Julius Caesar. And let us try and evaluate this cell. And as you must have noticed, we are not giving the description inside the struct, but while defining, we have defined that in case we don't have the value of description, at that time we simply want to initialize it to be a blank string, and that's why we are getting a blank string right over here. Next, we can use the case statement for our post. And suppose we want to pattern match on the author. So we can say that we want to have a case statement and we want to pattern match for our post number 1, and here let us define a couple of different scenarios. Now remember that since this is a struct, we can also use the map notation for our pattern matching. So here we can say that suppose we have an author, and in case the author name is Octallium, then we simply want to return a string got a post from Octallium. Let me copy and paste. Suppose the author name is Anil Kulkarni, so we can say got post from Anil Kulkarni. Next, we can also create a catch-all block, so we can use the underscore, and this time we can create a string and we can say got a post from, and we can use the string interpolation, so we can say post1 dot author, and let us try and evaluate. So this time we get the answer as got a post from Julius Caesar. Now just as a small reminder, we can easily update the struct as you would update a map. So in case we want to update the author field from Julius Caesar to my name, so we can say that we want to update the author to become Anil Kulkarni, and let us try to evaluate, and this time we have the new author Anil Kulkarni. Now let me create a new code block, and let me just copy and paste the case statement right over here, and let us try to evaluate. Oh, so this time we are still getting the answer as Julius Caesar, and that's because we are not rebinding over here. So we can say we want to rebind the variable of post number 1 to the updated value. So let me re-evaluate, and this also let us try to re-evaluate, and this time we get the right answer back. Similar to the case statement, we have another flow control mechanism by the name of condition. So let me create a new code block over here, and this is going to be for the condition, and here we can define a couple of different conditions to pattern match on. Now the condition statement does not take an expression right over here. Instead we can pattern match for the different conditions right over here. So suppose the first condition that we want to match would be for the post author, and suppose if we want to say that in case the author is Octallium, at that time we simply want to return a string back saying that editing a post from Octallium. Let me copy and paste this one, and this time let us check for the condition of Anil Kulkarni, and this also becomes Anil Kulkarni. Next, let us also define the catch-all block for the condition. Now for defining the catch-all block, we simply pattern match on the true condition, and we can say that in case we have a true condition, then we simply want to return a string saying that this is a catch-all. Now let us try to evaluate this cell, and we get back the answer as editing a post from Anil Kulkarni. Let us have a look at one more condition block. So let me create a new block right over here. We can also use this condition statement for more advanced pattern matching. So example, we have a list right over here, and suppose we want to pattern match on the first element. So at that time what we can do is we can simply use the head function. So we can say that we want to extract the head from our list, and in case the head is 1, at that time we want to return a message saying that got a 1, and let us define the catch-all block. So this time we can use a string interpolation, and we can say head is, and then we can put the head right over here. So let us invoke the function of head on the list, and let us try to evaluate this block, and we get the answer as got a 1. So as you can see, we can use all of the different pattern matching techniques for condition as well as case. The last flow control mechanism is the if and else block, but normally you will not have to work with the if and else block. We would use recursion or pattern matching instead of using if and else, but let me show you how we can use the if and else block if required. So let me create a new section. This section is for the if and else, and let us create a new code block. So the if and else condition is pretty much the same. So we can say if true, then we want to print out this will work, else we want to print out else this will work, and let us try to evaluate this cell, and we get the answer as this will work. Well, that's it for all of the different types of flow control mechanisms inside Elixir. Well, till now we had a very short introduction to the different data types and flow control mechanisms inside Elixir. From the next video, we will start working with a mixed project, and at that time we will learn all of these concepts in much more details. I think by now we have learned enough to start with the basic concepts of functional programming. So let us go ahead and let us start a new project. Now Elixir ships with a tool called as Mix, which stands for Mixing Elixir. So this Mix is like your project management tool. So let us see how we can use this to create our first project. So let me go back to my terminal, and I want to go inside my folder Functional Programming with Elixir. So right now I have created only one folder, which was for our scripts. Now let me create a new folder and let me name it as code. Let me go inside code. Here we can create a new project by saying mix new, and let me name the project as tutorials, and that's it. We have a new Elixir project. Let me go inside the folder of tutorials and let me open it up in my code editor. So as you can see, Elixir by default creates a bunch of different folders and files for us. So inside the lib directory, we can see that we have a module for the tutorials. Let me zoom in for you. The first main topic that we are going to learn in our journey of functional programming is all about recursion, and that's what we are going to start right in the next video. Now let's start with the most fundamental blocks of functional programming, and that is recursion. Now don't worry if you have never worked with recursion or if you find recursion very confusing. I will show you recursion step by step, line by line. I will also include a lot of diagrams and small animations to help you understand how recursion works. But for now, let us get started. So this is the mixed project that we created in the last video. Now I don't need all of this code. Let me just take it out and let me just save it. Now let's write a very simple recursive program to print the number of digits. So suppose you have a function called as up to, and if you pass 3 to it, then we should print 0 to 3. So it's a very simple program, but we will implement the program recursively. So inside the lib directory, I want you to create a new folder by the name of recursion. And inside this folder, let us create a file and let us call it as printdigits.ex. Now this time please remember that the extension is .ex because we want to compile this file. And if you go to test, here we can see that we have .exs. So these are script files and they are not meant for your production code. Now let me get back to the print digits and let me collapse my sidebar. Now remember that all of the code inside Elixir stays inside its modules. So the first thing is we need to define a module for this file. So let's create a module by typing def module, and this is the name recursion.printdigits. But the naming convention goes like this. First we normally include the name of our project. So we have named our project as tutorials, and let me open up my sidebar. So inside our project of tutorials, we have created a folder called as recursion, and inside that recursion, we have created a file called as printdigits. Now remember that this is just a community convention and it is not required. You can name this module anything that you want. Now with that in mind, let me collapse my sidebar. Now inside of this module, let us create a function called as up2. So we can define a function by using the keyword of def, and then we can say up to. Now this function is going to accept one parameter, and that would be for our numbers, and then we can start with the do and end blocks. Now suppose the number is 3, then we simply want to print out something like this. So we take the input as 3 and then we want to print digits from 0 to 3. So this is what we want to print, but we need to do this thing recursively. You must be thinking maybe we can just create a for loop. So we can create a for loop for I is equal to 0. Then we can say I less than and equal to your number, and then I plus plus, and then we can simply print out I. So if you're thinking we can do something like this, then the answer is no. because all of the data types inside Elixir are constants, they are immutable. And what's happening inside the for loop is for each iteration we are changing the value of I, which is right over here. So we can't use this kind of for loops inside Elixir. Then what can we use? So the answer is by using recursion. So let me take out the comments. First let me write the code and then I will explain what's happening. Now let's think of a base case. Suppose the number itself is 0, then at that time we don't have to do anything. So at that time we simply have to return back 0. So we just write 0 over here. Now remember that the last line inside your function automatically returns. So this is your automatic return statement and we don't have to use the keyword of return for the last line. Now remember that Elixir is a functional programming language. So essentially we have to return some kind of a value for each function. And in case the function is creating some kind of a side effect, at that time by default an atom of OK is returned. But for now let us continue with this program and let me write the next base case. So what we can do in Elixir is we can actually create multiple copies of the same function. This is also called as function overloading. And we can do this because Elixir supports pattern matching. So what we did right over here is we created a function called as up2 and we are pattern matching on 0. So in case if the number is 0, then we simply want to return 0 and that's it. Now we can create one more copy of the same function. So we can say define up2. This again accepts a parameter called as numbers and let's see what we can do this time. So this time what we want to do is we simply want to print out. So we can print out by using io.puts. So let us print out the number. But what we want to do is for each iteration we want to reduce the number by 1. So for example, if the number was 3, then after we print out 3, for the next iteration your number should become 2, then your number should become 1 and then your number should become 0. And when your number becomes 0, at that time we go to this line number 3 where we simply return 0 back. So the next question is how can we reduce the value of number by 1 each time? The answer is by using a recursive call to the same function. So for each iteration we can call ourselves back, but each time what we can do is we can say numbers minus of 1. So what we are doing is suppose this number is 3. So the next time when we call the same function, we are passing 3 minus 1. That means we are passing 2. Now don't worry if you find this logic a little bit confusing. We will see how to trace this function and how we can create recursive trees. So I will use a small diagram and small animation for it. But first let us run this file and let us see if it is working or not. So let me save the file and let me open up my terminal. Now till now we have been working with IEX, but this time we have created a project by using our mix tool. But fortunately we can use IEX along with our mix project as well. So here we can say that, hey IEX, I want you to start mix. So we just use the flag of hyphen and s followed by the mix command. So what happens in the background is IEX simply compiles your project and all of the modules are available to you inside our IEX. So let me clear up everything and let us call this function of up2. But remember that this function stays in this module. So what we can do is we can say from the module of tutorials, I want you to go to the module of recursion. From recursion, I want you to go to the module of print digits. And from here, I want to use the function of up2 and let us pass 3 right over here and let us see the output we are getting. So here it is. We are getting the output of 3, 2 and 1. So this 0 is not printing. If you want, we can print 0 right over here at line number 4. So if you want, we can replace this line by again io.puts and 0. But I think there is no point in printing 0. So we can take this one out. Or else we can also say that whenever we get a 0, we simply want to stop and we can return back an atom called as OK, which symbolizes that our operation was successful. Now let me save the file. Now since we have saved the file, we also need to recompile our project. Now here we have two choices. Either we can recompile the entire project or we can recompile just the module that we have changed. But each time typing such a huge module name is a big pain in the ass. So what we can do is we can create a small alias. So we can say that I want to create an alias for tutorials.recursion.printDigits. Let me clear up the screen, and now we can say that I simply want to recompile my module of print digits, and here it is, we have recompiled that module. Now let me clear it up one more time, and this time again we can use the module of print digits and we can invoke the function of up to. Now again, if you want, you can use the parentheses or you can leave them out. So let me just pass 3 right over here, and this time we get the output of 3, 2, 1 and OK. So let us go back to our code editor and let us see what's happening. So what's happening right over here is this is also called as your base case. So let me put up a comment right over here. So this you can call, this is your base case. So that means that in case if we get an input which is 0, at that moment we simply want to return some kind of a value and we want to exit from our recursive function. Now since this function returns a single value, we can use a much shorter syntax. So let me take out end, let me take out the return statement, and after the function definition I have to put a comma. After do I have to put a colon, and let me take out the OK from here and let me paste it right over here, and that's it. So this is also a valid function definition. So normally whenever we return a single value, that time we use a single line definition. Now instead of returning OK, let me go back to returning 0. So what's happening is we have a base case. Whenever we are getting the input of 0, at that time we are simply returning 0, but we are not printing anything. And in all other cases, we are first printing that number and then we have a recursive call. Now let's see how we can trace this function. So let me open up my browser, and so this is our function for print digits. So this print up to 0 and do 0, this is our base case, and this is our recursive function. So this line number 4 is a place where actual printing is taking place. And on line number 5, we have a recursive call to the same function. Now let's see how we can trace this function. Just imagine that the first argument we are passing to this function is 3. So for each iteration, what's going to happen? So Elixir is going to compare from top to the bottom. Is 3 and 0 equal? No, they are not. So Elixir will jump to this function definition. So let's see what's going to happen for this function definition. The first thing is we are simply telling Elixir to print out the value of number. So that's what is going to happen. So the first call is to print and we get 3 back. Now what happens next? So next is a recursive call to the same function but with the value of number -1. So let's see what's going to happen. So next is we are calling the same function back, but the value becomes 2. Now is 2 equal to 0? No, it's not equal to 0. So again Elixir will jump to this function definition. And again what happens? The first line is we simply want to print out the number. So we get the output of 2. And what happens on the next line? We are calling ourselves back, but this time again number -1. So the next call becomes up to and your argument becomes 1. Again the same thing happens. Is 1 equal to 0? No, it's not. So again Elixir will jump to this function definition. The first line is to print the value, so we get the value of 1 back. Now what happens over here? Again we have to call ourselves back, so again we call the same function, but this time the argument becomes 0. Remember 1 minus 0, that's why we get the argument here as 0. Now again Elixir jumps to the first clause. Now remember, Elixir scans your code from top to the bottom, and the first definition is up to with a pattern match of 0. And this time what's happening is we have a match. Since up to gets a parameter of 0, we simply want to return 0 back. So what's going to happen over here? So for this function, we are simply going to return 0 back, and that's it. Do we have any other calls left? No. So we simply exit, and that's it. We have the display of 3 to 1 in our console. So let me open up my terminal one more time, and here it is. We have the exact same output of 3, 2 and 1. So what we did right over here is we saw how we can trace our recursive program. So always remember to plot this kind of trees, and this will help you to understand recursive programming in a much better way. Now let us go back to the code, and this time let me make a very small change. Now instead of printing the number first, what happens if I print the number afterwards? Now let's see what happens this time. Let me open up my terminal one more time and let us recompile our module since we changed the code, and let me clear it up, and then let me again call the print digits up to and let us pass 3. So this time what happened? So instead of getting the output of 3, 2 and 1, we have the output of 1, 2 and 3. So what happened? We simply changed one line right over here and our entire output got reversed. So let us go back and try to trace this recursive program as well. So this was the earlier one and this is going to be the new one. So remember, we have the print statement afterwards, but first we are calling the function recursively. So let's see what's going to happen this time. So again, suppose that we are passing the argument of 3. So what happens? Is 3 equal to 0? No, 3 is not equal to 0. Then Elixir will jump to this function definition. Now what's happening in this definition? First we are calling ourselves. So what's going to happen? We have a recursive call and the parameter becomes 3 minus 1. That means we have a parameter called as 2. But what happens to this call at line number 5? Nothing. That statement remains unexecuted because first we have to exhaust this function right over here. So what's going to happen next time? So let us see right over here. So this call right over here, this does not execute. Instead, first we have to exhaust all of the parameters for this function. Now what's happening? The parameter is 2. Is 2 equal to 0? No, it's not. So we are going to go in this function definition. So what's happening this time? We again have a recursive call. So let us call ourselves back, but this time the argument becomes 1. And what happens to the print statement? Nothing. That is kept on hold right over here. Now let us go back to this function right over here. Is 1 equal to 0? No. So we go to this function. Again what happens? We have to call ourselves back. So let us call ourselves back, but this time the argument becomes 0. And what happens to the print statement? Again that is kept pending. Now what's going to happen this time? We are calling ourselves, but the argument is 0. So we have a pattern match right over here. And whenever the argument is 0, we simply give back 0. And that's what happened right over here. So this call right over here, this resulted in a 0. Now the control will go back to the previous function. Now what is pending in the previous function? This print statement is pending. But what is the value of number? So the value of number is 1. That's why we get the output of 1 first. Now again we have exhausted this clause. The control will go back to this one. Again what's pending? The print statement is pending. But what is the value of number? The value of number is 2. That's why we get the output as 2. Now again this function is exhausted. So the control goes back to this function right over here. Again what's pending? The print statement is pending. But what is the value of number? It's 3. That's why we get the value of 3 back. And this is exactly happening right over here. So we get the value of 1, 2 and 3. So what's happening over here is we can say that our print statement is executing in the return stage. But in the earlier example, our print statement was executing in the ascending stage. So we have a basic difference in the execution of our recursive functions. Let us try and summarize what we have learned till now. So what we have done is we have created a simple program to print out the digits, but we have implemented the logic in a recursive function. Now the only line of difference is right over here. In the first time, the recursive call is the last line inside this function. Now remember, the last line is automatically returned. We don't have to use the keyword of return. And this is creating a loop for us. Now when do we exit? We exit when we have a base case. And what is the base case? It's right over here. Whenever we get a 0, at that time we simply want to return 0, and this is the time when we exit from our recursive function. So we have two different function definitions. The first definition is for our base case, the second definition is for our recursive case. Now what we did in the second time is we simply changed our recursive call. So in the second case, first we have a recursive call and then we have the print statement. And what happened this time? The execution shifted from ascending stage to the return stage. So if I have to summarize further, here what's happening? The printing is done in ascending stage, and in the second case the printing is done in the return stage. That means the work or the execution happened during return and not during ascending stage. So this kind of function is also called as tail recursion. Now remember, in tail recursion we are calling the same function back, but each time with a different argument. And on the second case, this recursion is called as head recursion, because first we have the recursive call and then we have some kind of an execution left. Now you can see that we can create efficient loops in Elixir by using recursion, and that too avoiding all of the side effects by mutating our values. Well, that's it for this one. I hope you enjoyed the lecture on recursion, and I will catch you in the next one. So till now we saw how to print digits by using recursion, and we saw two methods, that was tail recursion and head recursion. Now let us get some more practice with recursion, and this time instead of just printing the digits, let us add all of the digits together. So for example, let us create a function called as up2, and if you pass the argument of 3, at that time we want to get the sum of all of the digits. So this function should return 3 plus 2, that is 5, 5 plus 1 is 6. So this function should return us 6. So let us go ahead and let us create the file for this one. So inside the directory of recursion, let me create a new file and let me call it as sumofdigits.ex. The first thing, we want to define a module, and as per the community convention, let us write the application name first. So the application name is tutorials, and then the folder is recursion, and then the file name is sum of our digits. Let me collapse my sidebar. Now here let me first write a very simple recursive function, and then we will try and trace that function. So let us call a function by the name of up2, and let us pass the argument for the numbers, and let's see what we can do this time. So this time we can use a very simple recursive function. We can say that for each iteration I simply want to add the number, and the next time I want to call the same function of up2, but every time my argument should be number minus of 1. But this function will never end because we don't have a base condition. The number will keep on going into negative values. So we also need to define a base condition. So on the top, let us create the base condition. So let me create a new function by the name of up2, and this time let us pattern match on 0. Suppose the number is 0, then at that time I simply want to return back 0. Now remember, if we have a single line of return, then we can write it on the same line, and in case if we have a regular function, then the last line is automatically returned. We don't have to use the keyword of return. So let me save the file. First let me run the file, and then we will try and trace the recursive function. So let me open up my terminal and let us enter inside IEX. So I can say IEX.s, that stands for start. I want IEX to start my mix, and let me clear all of these things. Let us create an alias. So you can say I want to create an alias for tutorials.recursion.sumDigits. Let me clear up the screen, and now we can say from the module of sumDigits, I want to use the function of up2, and let me pass the argument of 3. So as expected, we get the answer as 6. So what happened? 3 plus 2 plus 1 is equal to 6. Now let us see how we can trace this recursive function. So this is our program for sumDigits, and this is the functions that we wrote. On line number 1 we have the base case, and on line number 3 we have the recursive case. Now let us see what's going to happen. Let's take the same example and let us pass 3 to this function. Now is 3 equal to 0? No, 3 is not equal to 0. So Elixir will go to the next function, and here what's going to happen? Here we are saying that we want to add the number, and after adding the number we simply want to call the function recursively. So what's going to happen is we get 3 plus, and again we call back the same function. but this time the argument is number minus 1. That's why the next time we are calling the same function up to with an argument of 2. Now what's going to happen? Is 2 equal to 0? No. So Elixir will go to the next function. Now what happens? Again the same thing, number plus the recursive call. So what's going to happen is, so this will evaluate 2, we get the number, so the number in this case is 2, so 2 and plus, and then we again get back the recursive function, but this time the argument is 2 minus of 1, that's why the argument becomes 1. Now again let us go back to the same function. Is 1 equal to 0? No. Then we will go to the next function. Now here again the same thing repeats. So this time again the number plus, that means 1 plus, and let us call the same function again, but this time the argument becomes 0. So what's going to happen this time? This time we have a base condition in place, which is right over here. We are saying that whenever the argument is 0, at that time we simply want to return back 0. So this function right over here, this will simply return back a 0. So now what has happened? We have exhausted this call, and now the control has to return back to the earlier functions. So what's going to happen? So this entire expression 1 plus of this function, this will be evaluated to 1 plus 0 is equal to 1. So this entire expression evaluated to a 1. Now the control will go back to this function right over here, but this time what's happening? So this entire function call evaluated to a 1. So what's going to happen right over here? This entire expression would be evaluated to 2 plus 1 is equal to 3. Now again the control will go back to the earlier function call. So this time what's happening? The function call of up to and 2 has evaluated into a 3. So this entire expression gets evaluated to 3 plus of 3. That means we get back a 6. And this is what is returned from our function, which you can see right over here. Now if you have a look at this function is neither head recursive, neither it is tail recursive. It is just a recursive function. But can we convert this function into a tail recursive function? Yes, we can. So let me show you how we can convert this function from a regular function to a tail recursive function. So let us create a new function right over here, and we can say that this time the up to function would be tail recursive. Now first let me write the function definition, and then I will explain what's happening. So this function is going to accept two different parameters. The first parameter is the number as it is, and I also want to accept one more parameter which I am going to call as accumulator, so which stands for ACC for short. Next, let us think of our base condition. So as we just saw over here, we have a base condition where the number is 0. So let's try and replicate that same logic right over here. So in case if I say that my number itself is 0, then at that time I simply want to return back my accumulator. So I can say do ACC. So this is our base condition. Now let us see how we can define our recursive condition. So let me copy and paste right over here, and this time we want to get a number, and let us take the return statement in a different line. So let me take it out. Now let's see what we can use as our recursive call. Now again, please let me repeat. First let me write the code, and then when we see how to trace the recursive algorithm, at that time the logic will get clear. But right now what I want to do is I simply want to call the same function again, but for each iteration I want to say that my number has to decrease by 1, and for each iteration I simply want to add my accumulator with the number, and that's it, we are done. So let me save the file and let me open up the terminal, and now I can recompile the module of some digits. Now let me clear up the screen, and we can say that we want to use the tail recursive version, and let me pass 3 to this one. Oh, we have an error. That's because we also need to pass the accumulator. So this function, the tail recursive, requires 2 arguments, and I pass only a single argument. That's why we get an error. So let me clear this up, and we can say that the accumulator has to be 0, and this time we get the answer back as 6. Now we can slightly improve our program. Each time, instead of passing an accumulator, what I can do is I can simply set the default values. So let us go back to the code editor, and let me copy and paste this line. So what we are going to do is we are going to create a function definition, and since we are just creating the function definition, or you can say just the function header, we don't need to specify the return statement, so this has to go. And here we can say that the default value of the accumulator is 0. So in case the accumulator is not specified, at that time the accumulator would be set to 0. And here instead of 0 we can say that the first argument can be any number. So what we have done right over here is we have simply created a public function. So as our code editor is helping us, it's just a public function with a given name and body. So normally these things, they help you with the documentation of your code. The first thing, we again need to recompile our module of sum digits. Let me clear up the screen and let us try to invoke the same function. But this time, since we have a default argument for the accumulator, I can simply leave it out. And again, we get the same answer back as 6. Before we go ahead and trace this recursive function, we can do one small thing. Now what happens, this function is slightly expensive because it takes slightly more memory. So what we can do over here is we can simply call the tail recursive function and pass the argument of number, and that's it. So now let us open up our terminal and let us again recompile. Let me clear up everything. And this time if I do sum digits dot up to, and if I pass the argument of 3, so what's happening? Behind the scenes, we are still invoking the tail recursive function and we are getting the same answer back as 6. So now let us go ahead and let us see how we can trace the tail recursive function. So this was the last function. Now we want to trace the tail recursive function. On line number 2, we just have the function definition. So this function accepts a number, and for accumulator we have set the default value as 0. On line number 3 we have the base condition, and we are saying that whenever we get the number as 0, at that time we simply want to return back the accumulator. The next is our recursive call. Now let us pass the argument of 3 to this function and let us try to trace this recursive function. So we have an initial call like this. The value of number is 3, and by default the accumulator is set to 0. Now let's see what's happening. Now is 3 equal to 0? No, it's not equal to 0. So Elixir will go to this function right over here. Now what's happening? Now we are calling the same function back. Okay, so what we need to do, we need to call the same function back. But what happens to the argument? So the first argument is we simply want to decrement the number by 1. So in this condition, what's happening? The number is 3. Okay, so we get 3 over here. And for each call, we simply want to subtract 1 from it. So the answer here is 2. And the next parameter is right over here. So we simply want to add the accumulator with the number. So let's go right over here. So what's the accumulator? So as you can see, initially the accumulator is 0. So we get a 0 right over here. What's the number? The number is 3. So 0 plus 3, we get a 3 right over here. So this entire function would look something like this. The new number is 2 and the new accumulator is a 3. Now let's see what's going to happen. Is 2 equal to 0? No, it's not. So we will go inside this function. Again, we have to recursively call the same function. So let us see what's going to happen. So again, we call the same function. But this time what happens? The number is -1. So this 2 comes over here, minus of 1. So what's the remainder? It's 1. The next is accumulator plus the number. So in this case, what is the accumulator? The accumulator is 3, which comes right over here. What is the number? Number is 2. So 2 comes over here. So 3 plus 2, we have a 5. So this function gets evaluated to right over here up to the number becomes 1 and the accumulator becomes 5. Now again the same thing, we have to call ourselves back again. Now is 1 equal to 0? No. So we go to the next condition and again we call ourselves back. So what's going to happen this time? So this time number is 1, 1 minus of 1. So that's why we get a 0 right over here. The next is again the same thing. Accumulator plus the number. So what's the accumulator? The accumulator is 5. That's why we get a 5 over here. What's the number? The number is 1. So we get a 1 over here. So 5 plus 1, we get a 6. That means we can say that this expression is evaluated something like this up to 0 and 6. Oh, so this time the number becomes 0. So what's going to happen? So it's going to go right over here. So is the number 0? Yes, the number is 0. So what do? We simply return back the accumulator. So that's what is going to happen right over here. We simply have to return back the accumulator. So what's the accumulator? The accumulator is 6, and that is what we have to return. So now is anything left? Nothing is left, and that's it. We get the answer back as 6. So as you can see, these tail recursive functions are very special. The first reason is they require less memory. And why do they require less memory? It's because they are recursively calling themselves back again. Now, if you come from some other compiled language like Java or maybe like Python, you must be thinking that for each of these calls, we must be allocating different stack memory. But no, that does not happen in Elixir. Since Elixir is a functional programming language, these function calls are highly optimized. So what's happening? We are simply reusing the same stack, and hence there is no extra memory allocation. So always, whenever possible, try and use tail recursive functions because they are more memory efficient. In terms of speed, it could be more, it could be less, you don't know. But in terms of memory, for sure, they require much less memory. Well, that's it for this video, and I will catch you in the next one. Let's have some more practice with our recursion. In the last video, we wrote a very simple recursive program to calculate the sum of the different digits. But for this video, I want you to calculate the factorial of a number. First, let me get this back to the old code. So the old code was number plus of up to, and then we simply want to call number minus of 1. So this time what I want you to do is I want you to write a program for calculating factorial. So for example, if we have a number like 3, then the factorial would be like this: 3 into 2 into 1, and the output would be 6. So I want you to pause this video for a moment and try it on your own. So I hope you were able to do it. If not, let us do it together. So first let me create a new file, and let me call that file as factorial.ex, and first let us create the module. Let us get the module name right. This has to be tutorials.recursion.factorial, and here let me create a function called as off, so we can simply call factorial.off. So the first condition is, in case if I get 1, at that time I simply want to return 1 back. Next, let us write the recursive case. So in case we get some other number, so we can say number, and this time let me show you how you can calculate by using a regular recursive program. And after that, I will also show you how to write this program by using tail recursion. But for now, let us go with the flow. So here we can say that for each iteration, we want to multiply a number, and we simply want to call ourselves back each time. But each time we want to decrement the number by 1. So this is a very simple recursive case. Let us open up our terminal. Let me clear up everything, and let us use our IX. Let me adjust my terminal as well. Here we can create an alias. So we can say tutorials.recursion.factorial, and let's call our function. So we can say factorial of, and let us pass 3. So we get the answer as 6. Let us try with 4. So we get the answer as 24 back. Now let us try and trace this recursive program and see what's happening. So this is the first recursive program that we wrote. So here we have the base condition define of. If we get 1, we simply want to return 1. Otherwise, we want to call this function. So now let us try and trace what's happening. So suppose we invoke this function with an argument of 3. So at that time, what's going to happen? So is 3 equal to 1? No. So Elixir will go to this function, and now what's going to happen? We have to multiply the number and call the function itself again. So here it goes. We want to multiply 3, and we want to call the same function one more time. But since we are decrementing the number by 1, so this time the argument becomes 2. Now again, is 2 equal to 1? No. So we will jump to this function. Again, the same thing will happen. We first have to multiply the number and call the same function one more time. So this time again we have 2, and this time 2 multiplied by the same function, and the new argument is 1. So in the next iteration, we have a match on the base case. So since we have a match, we simply have to return 1. So this function would be evaluated to a simple 1. Now the control will go back to this statement right over here, 2 multiplied by and this function. So this would be evaluated to 2 and this one comes right over here. So this entire expression would be evaluated to a 2. Now the control will again flow back right over here. So this one would be evaluated something like this, 3 multiplied by 2 and we have a 6. Now there is nothing on the top, we have exhausted this function as well. That's why we get the return value as 6, which is the factorial of 3. Now let's go back to our program. So this was a very simple recursive way of creating the factorial. Next is, can you write the same program but by using tail recursion? So if you can, just give it a pause and try it on your own. Otherwise, I will show you how we can write the same program by using tail recursion. So let me create a new function right over here and I can say off, but this time it's going to be with tail recursion. This function is going to accept 2 arguments. So the number 1 would be on number. And for the tail recursive function, first let us create the base case. So here we can pattern match on the number. So we can say that in case the number is 1 and the second argument is our accumulator. So this time I simply want to return back my accumulator. So don't worry if you don't understand, we will trace this program as well. Next comes our recursive case. So we can say of our tail recursive version. So the first argument is our number, the second argument is our accumulator. So here I can say that for each iteration, I simply want to call the same function again. So of tail recursion, but for each iteration, I simply want to decrement my number by 1. And for each iteration, I also want to multiply my accumulator with my number. Next, we can do one slight improvement for this program as well. We can also have a default value for the accumulator. So let us go ahead and let us create the function definition on the top. So remember that the function definition always goes on the top. So here we can say we want to define of our tail recursive function. The first argument is always going to become the number. The second argument is our accumulator. And for the accumulator, we want to have the default value of 1. And since this is just a function definition, we don't have to write the body of this function. And let me open up my terminal. And since we have changed the contents of the module, first let us try and recompile this module. Now let me clear up everything. Now let's try and use the tail recursive version. So we can say factorial of, this time we want to use our tail recursive function and let us pass the argument of 3. So we get the answer back as 6. Let us try one more time with 5, and for 5 we get the answer as 120. So now let us go and try and trace this recursive program as well. So this is our tail recursive version. So as you can see, for the first line we have the function definition. The first argument is the number and we have the default value for the accumulator and the default value is 1. Next we have the base case and here we simply want to pattern match on the number. So we are saying that in case the number is 1, at that time I simply want to return back my accumulator. Next we have our recursive case. So for each iteration we simply want to decrement the number by 1. And we also want to multiply our accumulator with the number. So now let us see what's going to happen with this one. Suppose we invoke the function with an argument of 3 and the default value for the accumulator is 1. So for the next iteration, what's going to happen? So is 3 equal to 1? No. So Elixir is going to jump right over here. So what's going to happen this time? We want to call ourselves back. So this function will call itself back. But this time the first argument is number minus 1. So 3 minus 1, that's why we get a 2 right over here. And for the next argument, we simply want to multiply the accumulator with the number. The accumulator is 1, the number is 3, so we get a 3 right over here. So this function would look something like this. So next again, so is 2 equal to 1? No. So we have to call ourselves one more time. So again, this time what's going to happen is we want to decrement the number by 1. So this evaluates to a 1 and we also want to multiply the accumulator with the number. So the accumulator is 3 and the number is 2, so we get a 6 right over here. And this function would look something like this. What's going to happen this time? Oh, so this time we have a match on the number and we are pattern matching and saying that in case the number is 1, at that time we simply want to return the accumulator. So this function would evaluate to something like this. We simply have to return back the accumulator and the accumulator is 6 and that's your final answer. And after this we simply exit because there is nothing else left to do. So just as a small tip, whenever you are feeling confused with recursion or if you don't know what's happening inside your recursive calls, it's always a good idea to draw this kind of recursive trees, and for sure they will help you to understand recursion in a much better way. Well, that's it for this video and I will catch you in the next one. Let's have some more practice with our recursion, and this time I want you to write a program that will reverse the numbers. So in case the number is 1, 2, 3, then the output should be 3, 2 and 1. And what I've done is behind the scenes I have created a new file called as reverse number inside recursion, and I have created a blank module for this one. Now here you can use your own logic to reverse the number, or if you want some reference I have given a simple algorithm right over here, but it's not required to follow my logic. If you can do it in any other way, you are welcome to do it. So let's see what steps I have given right over here. So for example, the number is 123, then the output should be 321. So for this case, suppose I want to write a tail recursive version. At that time, I want to have one more variable called as accumulator, and I want to set the default value of accumulator to 0. Now again, it's not necessary for you to write a tail recursive version. You can write any version that you seem fine. But I am going to write a tail recursive version for this one. That's why I have taken one more variable. Next, what I am doing is I am creating a loop, and for each iteration I want to create a new number and a new accumulator. So let's see what's going to happen for the new number and for the new accumulator. For each iteration of the loop, I simply want to divide this number by 10 so that I get a new number each time. So for the first time, the number is 123. So 123 divided by 10. So I get the answer as 12. Now for the new accumulator, there are two steps. The first step is I simply want to multiply my existing accumulator by 10. Now the existing accumulator is 0. So 0 multiplied by 10. That's why I have a 0 right over here. So this was the first part. And the next part is I also want to take the remainder of this number. So I'm using the mod operator. So here what's going to happen is the remainder of 123 and 10 is 3. And the final step is 0 plus of 3, and we get a 3 right over here. The next thing is I want to continue with this loop till the time my number becomes 0. But right now my number is 12. So this number changes from 123 to 12, and the new accumulator is 3. That's why this 0 changes to a 3. Now is my number equal to 0? No. So we continue with the loop. So for the next iteration, our number is 12. So 12 divided by 10, we get a 1 right over here. And for the new accumulator, the value inside the accumulator is 3. So 3 multiplied by 10, we get a 30 right over here. For the next part, the number is 12. The remainder of 12 and 10 is 2. So here we have 30 plus of 2. That's why this will evaluate to 32. Now again, is my number equal to 0? No. My new number is 1 and my new accumulator is 32. So we continue with the same loop. Now this time my number is 1. So 1 divided by 10, I get a 0 right over here. Then for the new accumulator, my value inside the accumulator is 32. So as you can see right over here, we have 32. So 32 multiplied by 10, that's why we get 320 right over here. The next part is the number is 1. The remainder of 1 and 10 becomes 1. So here we have 1 plus of 320. So we get 3, 2 and 1 right over here. So what happens now? Your number has become 0 and your accumulator has become 321. And since your number becomes 0, we simply want to return back the accumulator, and the accumulator is 3 to 1, which is exactly the reverse of 123. Now before you attempt this question, let me show you one more thing. In Elixir, if you do something like this, 123 divided by 10, here you can see that we get back a float value. But if you want to get back an integer division, then you can use the inbuilt function of div for division. So we can say we want to divide 123 by 10 and we get back the integer value of 12. Now for calculating the remainder, we don't have the modulus operator. Instead, you can use the inbuilt function of remainder. So we can say that we want to get the remainder of 123 with 10 and we get back the value of 3. So with these things in mind, I want you to try this program. Now again, let me repeat, you can use your own logic and just pause this video for a moment and try it on your own. Otherwise, we will do it together. So I hope you were able to do it. If not, let us do it together. I am going to write a tail recursive version for this program. And the first thing which I want to do is I simply want to define my base case. And what is my base case? My base case is right over here. So if my number is 0, then I simply want to return the accumulator. Let me create a function called as off, and this function is going to accept two parameters, my number and my accumulator. And my base case is something like this. In case my number is 0, then I simply want to return back my accumulator. So this is our base case. Now let us define the recursive case. So we can say that the function of off is going to accept one parameter for the number, the second one for the accumulator, and let us create the do and end blocks. Here we can say that my new number is going to be the integer division of my number with 10, and also for each iteration I want to create a new accumulator. So I can say that my new accumulator, again let us use the logic that we have defined over here. So the logic goes like this. For each iteration, I simply want to multiply the accumulator with 10. And for the next part, we simply want to add the remainder of the number along with 10. Now the only thing left to do is to simply call the same function one more time. But this time the argument is going to be our new number. And here we have the new accumulator. Now here we also need to set the default value of accumulator to 0. So let me create a function definition on the top. So we can say that function of off accepts one parameter by the name of number. The second parameter is called as accumulator. The default value is 0. Now since this is just the function definition, we don't have to create the body. Let me save this program. Let me open up my terminal. Now since this time I have added a new file, let us recompile the entire project. So we can say that I want to recompile. Then let me create an alias for tutorials.recursion.reverse number. Oh sorry, I spelled it wrong. So it has to be alias. Let me clear up the screen, and now let us try our newly defined function. So we can say that reverse number of, and let us pass the argument of 123 and we get the right answer back. Let us try with 1 2 3 4 5 and we get back the answer of 5 4 3 2 1. Till now we have seen how to work with recursion inside our Elixir. Now it's time to see how we can combine list along with our Elixir. And I can't emphasize more that the lists inside Elixir are not your regular arrays or lists. Lists inside Elixir are actually linked lists. So even if a list looks something like this, it's not what it looks like. So for those of you who don't know what is a linked list, here it goes. So here we have 3 different nodes. And for the first node, the data inside the head is 1. So as you can see, the data inside the list, this one actually looks something like this inside the memory. So this entire thing, this would be your node number 1, and the data inside your head would be 1. The darker portion that you can see over here, so this is going to be your tail of your node number 1, and this tail is actually pointing to yet another node, and the data inside this node is 2 that you can see over here. So this entire structure, this is our node number 2, and the data inside the head is 2. Now again, this node also has a tail, and this tail is pointing to yet another node. The data inside the node is 3, and as you can see, this is going to be our node number 3, the head, and the data inside the head is 3. Now if you have a look at the list, we don't have any other parameters left. So the tail of your node number 3, this would actually point to something which is null. That means it is not pointing to anything else. So this is how a linked list would look inside the memory. Now just to refresh your memory, let us go back to our terminal. So we can say that we have a list and the elements are 1, 2 and 3. Now as we just saw, we have 3 different nodes, and if you want to see the head of the first element, then either you can use the built-in function for the head, or we can also use pattern matching. And in case if you want to use the pattern matching, then we can say that the first element should be head, then we need our cons operator, then we need one more variable for the tail, and let us pattern match on list. And here we can see that the head is 1 and the tail is 2 and 3. Now suppose we have one more list, let us call it as list number 2, and this has a single element of A inside of this list. Now what happens if I try to pattern match on this list? So let us pattern match and see. Let us write the head, and we also want the tail, and this time we want to pattern match on list number 2. So as you can see, the data inside our head is A, but what happens to your tail? Let us check it out. So as you can see, the tail is blank. That means we have exhausted this linked list and there are no more elements left. So keep this pattern in your mind, and we will see how to work with recursion and lists right from the next video. So let us get started with linked list. But before we can get started, I wanted to show you a couple of things. So let us go back to our terminal, and I am inside my IEX. Now in case if I want to see the info for a list, so let's create a list 1, 2 and 3. Here we get back a couple of information parameters for our list, and here we can see that we have a couple of implemented protocols, and one of the most important protocol is this one. So this stands for enumerable, that means in short as enum. And let us go to the official documentation, and there I can explain all of these things. So this is the official website for Elixir, it's elixirlang.org. Let us go to docs, and here we want to see the documentation of the current stable version. So this takes us to a new website, and as you can see, this website is called as hexdocs.pm. So hex is like the package registry for Elixir. So in case if you go to this website hex.pm, and here we can search for different packages. Suppose you want to search for Phoenix, then you can search for Phoenix right over here, and this is going to list all of the packages. So this is the official package for Phoenix, and if you click on the online documentation, it will take you to the docs page, and this is the official documentation for Phoenix. Now let us go back to the documentation for Elixir, and as you can see, we have 2 tabs right over here. So this tab is for the pages and this tab is for the modules. Now this module of kernel is automatically imported for us. We don't have to import this kernel. The next module which I wanted to show you is for our list. So let us scroll a little bit down, and inside this section of collections and enums, we have our list right over here. And here we can see that we have nice documentation in place, and also we have a couple of functions that are implemented on the type of list. So here we can see we have different functions, and if you want to see documentation for any of the functions, you have to just click on this one, and this opens up the documentation for the requested function. Now in the terminal, we saw that list also implements the protocol for our enum. So let us check out the documentation for enum. Let me collapse my list, and let us go to the documentation for enum. So enum basically helps you to iterate over your list or any of the collections, and most of the functions for your iterables are inside enum, and some of them could be in list or maps or hash map, but enum would be your most frequently used module. And as you can see in the documentation, the first example itself uses a list. The second example also takes a list and simply gives back the sum of the list. So what we can do is let us try and replicate this functionality by using our list and recursion. So now let us go back to our code editor. Now here let us create a new folder. So inside my directory of lib, let us create a folder by the name of list, and inside this folder let us create a new file by the name of list.ex, and let us first define the module. So this has to be .tutorials, and this naming convention doesn't make any sense. So right now let me just take out this list and let us name the module as tutorials.list. So let me define a function called as sum, and this is going to take a list of our numbers. Now first let us think of a base case. Suppose we get an empty list, so at that time we can simply return back a 0. So let me define a base case on the top. So I can say define my sum, and let us pattern match on an empty list. So we can just write empty list right over here. So in case we get an empty list, we simply want to return back a 0. So now let us see how we can write the recursive case. Now what we can do is this parameter of numbers, this is actually a list. So we can pattern match right over here. So what I can do is let me take out this parameter and let us pattern match inside the function definition. Let us collect the head inside a variable called as h, and let us collect the tail inside a variable called as t. Now let us see what we want to do for each iteration. We simply want to add the head along with the sum, and each time we simply want to pass the tail. And that's it, we have a recursive function for adding all of the elements inside the list. Now as you can see that this is not a tail recursive version. So what we can do is let us try and rename this file. So instead of calling this as sum, let us rename this function from sum to sum simple. And here what we can do is, since this is just one single line of return, let me take it to a single line. Let me put the quotes, and we don't need the end block. And let us open up our terminal and see if this is working or not. So let me go inside my IEX and let me clear up my terminal. And here we can say that from the module of tutorials, I want to go to the module of list. Then I want to invoke the function of sum simple, and let us pass the list of 1, 2 and 3. And as expected, we get back the answer as 6. Now what we can do is we can also write this function by using tail recursion. So let us see how we can create the tail recursive function. So we can call that function as sum and tail recursive, and let us think of different parameters that we can pass for our tail recursive version. This function will accept two parameters. The first is obviously our list of numbers, and we also need an accumulator. And what we can do is let us define the function definition right over here. So we can say that the default value for our accumulator has to be 0. And now since we have just created the function definition or the function header, we don't need to create a body for this one. Next, let us write the actual implementation. So let me just copy and paste. So here we don't need the default argument. And first let us think of the base case. So in case the numbers is just an empty list, so at that time we simply want to return back our accumulator. The next is our recursive case. So let me again copy and paste. Now this time again we can pattern match on the head and on the tail. So we can say that we want to collect the head and we also want to collect the tail. And for each iteration we simply want to call the same function back. But now for each iteration, we simply want to pass the tail. We don't need to pass the head for each iteration, and our accumulator becomes our accumulator plus of our head. And that's it. We have a tail recursive function as well. Now let us do one simple thing. Let me go at the top, and here let me create a function which is called as sum, and this accepts our numbers. And here let us simply call the tail recursive version. So we can say that I want to call my tail recursive version, and let me pass numbers to it. So now we have a much smaller name, and this makes our life much more easy. So let us go back to our terminal. Let us recompile tutorials.list. Let me clear up the screen, and let us invoke the same function, but this time the name of the function is just sum. and as expected we get back the answer as 6, and this time for calculating the sum we are using the tail recursive version. Now going forward, I'm not going to draw the recursive trees, but if you are not feeling confident or if you're feeling confused, then I highly motivate you to draw the recursive trees. Now before ending this video, I wanted to show you a couple of things. The first thing is, let us see how we can document all of our code. The first thing is we can use something which is called as module attributes. So on the top we can say that we want to create documentation for the entire module. So let's document what we are going to do for this module of list. We are going to implement a couple of functions that can be used on the list. So I can create a heading for our function summary, and the first one that we have implemented is for our sum. So this is how you write the module level documentation. Next, let me show you how we can write the documentation for our function. So for this we can use the module attribute of just doc, and inside the quotation marks let us write the documentation saying that this function returns the sum of the numbers inside a list. So now if you hover over the definition of sum, we can see that the code editor is showing us the documentation. And the last thing which I wanted to show you in this video is how we can define the type specifications or the type hints. So here we can use another module attribute by the name of spec. So this stands for the function specifications. So here we want to define the specifications for our function of sums, and here we can define the type of this parameter. So in our case, sums is actually a list, and the list contains different numbers. So this is how we can define the type of numbers. The next comes the return type. So here we can put double quotes and we can say that the return type is also going to be a number. So what we have done is we have also added the documentation and we have also added the specifications. So in the future, whenever you are using tools like Dialyzer, it will help you to catch bugs inside your code. Next, let us write the specifications for our other functions as well. So let me copy this one and let me paste it right over here. This function is going to be our sum of simple. Next, let us also write the specification for our tail recursive function. So here I can say that this function name is actually my sum of tail recursive. Now this function accepts two parameters. The first parameter is a list of numbers. The second one is simply an integer. So we can say that the second parameter is an integer and the return type is number. And if you want to read more about the type specifications, then we can go to the official documentation and we can go to the tab of pages, and here we can see that we have the documentation for our type specifications. Right now, don't worry too much about type specifications. I will show you how we can write the specifications from here on. Well, that brings us to the end of this video and I will catch you in the next one. Now let us see how we can reverse a list inside Elixir. So for example, we have a list and this list has two elements, 2 and 3. So this list would look something like this inside your memory. So we have two nodes. So this node is for 2 and this node is for 3. Now here goes my question. Suppose we have two more nodes. On the left here we can see that we have one node, and on the right here we can see that we have one more node. So now the question is, would adding this node to our list of 2 and 3 would be faster, or adding 4 to our list of 2 and 3 would be faster? So what do you think? This operation would be faster or this operation would be faster? So the answer is adding this node would be faster, and this happens in constant time. And the reason is we don't have to traverse throughout this entire list. We simply take a node and we simply point the tail to an existing list, and that's it. But what happens if we want to add a node at the last? At that time it is not efficient because it is going to take a linear time, and adding this node takes a linear time because we have to traverse through the entire linked list. So in this case we have to go from this node to this node, and after that we can point the tail of this node to our last node. So it takes linear time. So just keep this thing in mind that adding a node to the head would be always faster, and adding a node at the last would take linear time. With this logic in place, let us see how we can reverse a list. So for example, we have a list right over here and we have elements of 1, 2 and 3. So at that time we will take one more accumulator list, and for each iteration we will take the head of this one and we will insert that head inside our accumulator list. So what happens for the first iteration is we simply take out the head and we insert the head inside our accumulator. Now here, since we are inserting at the head, this operation takes constant time. And for the next iteration, what happens, since we have taken out 1, your list now becomes 2 and 3. So for the next iteration, we simply take out 2 and we add 2 to the head of our existing list. Now again, since we are adding to the head, this operation also happens in linear time. Now going to our original list, since we have taken out 2, we have just one element left. And the same thing happens, we simply take the 3 out and we add 3 to the head of our accumulator list. And that's it, we have reversed a linked list, or rather we have simply reversed a list inside Elixir. So let us write the code for this one and let us see these things in action. So here let me put up a comment. This is going to be our function of reverse. Here let us define a function called as reverse. Now this function accepts 2 parameters. The first one is for our elements, the second one is for the accumulator, and let us define the function signature right over here. So in case the accumulator is not given, at that time we simply want to set the accumulator to be a blank list. The next comes our base case. So let me copy and paste, and here we can pattern match, and we can say that in case we have a blank list right over here, at that time we simply want to return back our accumulator. So here I can say do and my accumulator. The next comes our recursive case. So again let me copy and paste. Now here what we can do is we can simply pattern match for the list. So we can take the head and we can also take the tail, and for each iteration we have to call the same function back. Now let us see how we can pass the arguments for our tail recursive function. First, let us write the argument for our accumulator. So if we go back to our diagram, so here what we want to do is we want to take the head and we want to insert the head inside our accumulator. So that's what we can do over here. So we simply want to take the head and we want to add the head to our accumulator. Now let us again go back to the diagram. Now since we have taken out 1, our list for the next iteration should be 2 and 3. And we can very easily do that. So for the next iteration, we simply have to pass the tail back. And that's it, we have a very nice tail recursive program to reverse our list. So let us try this program inside our IEX. So let me open up my terminal. Let me go inside my IEX. Now here let me clear up my screen, and I can say that I want to go from my module of tutorials to my list and I want to reverse. And let us pass the argument of 1, 2 and 3, and as expected we get back the answer as 3, 2 and 1. Now the last thing inside this video is let us also write the specifications for this function. Here we can use the module attribute for our specifications, and we can say that our function of reverse. Now here we can say that elements is actually going to be a list. And since we don't know what type of elements would be there inside the list, we can say that they can be of any type. And the same thing goes for our accumulator as well. Here let me show you one more alternate syntax. So instead of writing list, we can simply write a list like this, and inside the list we can specify that this list can hold any kind of elements. And again for the return type, we can say that the return type is also a list, and this list can hold anything, so we can specify any right over here. And just for the sake of consistency, let me convert this as well. So let me put square brackets, we don't need this. And that's it for this video. I'll catch you in the next one. Next, let us see how we can implement the map function. But first let me show you what do I mean to say. So here let us see the documentation. So I want to go to my module of enum and I want to see the documentation of map. So as you can see over here, so this map function, this takes a list of elements and it also takes a function. And what does it do? For each iteration, it simply applies this function to the element. So for example, we can see that the first element is 1 and this function is taking 1 and it is giving back 1 multiplied by 2. That's why we have the answer of 2 over here. Now we move to the next element. The next element is 2. So 2 multiplied by 2, we get a 4. The next one is 3. 3 multiplied by 2, so we get a 6 right over here. And we have one more example right over here. So in this case, this is a keyword list. And what this function is doing, it is pattern matching on the key and value pairs, and it is simply changing the value from a positive to a negative number. So for the first iteration, your key is the atom of A and the value is 1. And what this function is doing, it is returning back a negative value. So we have -1 right over here. For the next iteration, the key is the atom of B and the value is 2. And here we are simply flipping the sign. So that's why we get -2 right over here. So let us see how we can implement this function by using our list. So let us go back to our code editor. And here let us create a new function called as map, and let us see how we can implement this functionality. So this function is going to accept 3 parameters. The first is for our elements, the second one is for the function, and the third one is obviously our accumulator. And also let us set the accumulator to be a blank list. Now before we can go ahead, I wanted to show you one more thing. All of these functions that we are defining inside the module, so this function of sum simple, sum of tail recursive, reverse, all of these functions are called as named functions, and they are called name functions because all of these functions belong to a module, and in our case the module is called as tutorials.list. But in case for this function of map, we are passing an anonymous function. So this function does not belong to any module. So let us see how we can work with our anonymous functions as well. So what we can do is either we can create an anonymous function right where we require, or we can define it separately as well. So suppose we define a function called as double, and we can say that this is going to be an anonymous function, and this function accepts some element and it simply returns that element multiplied by 2. Now remember the syntax, the opening is by fn, that stands for your function, the end happens with your end block right over here. Now in order to use this function, we have to use a dot notation. So in order to invoke this function, we can say that we want to invoke the anonymous function of double, but we want to pass the value of 2. And as you can see, we have to use the dot notation since this is an anonymous function. So keeping this thing in mind, let us go back to our code editor. So let me scroll down to our function definition, and here it is. So as usual, first let us think about the base case. So let me just copy and paste. So the base case would be in case the elements are blank, that means it's just a blank list. At that time, we simply want to return back the accumulator. So we can say do and our accumulator. Now here what happens is we don't need this argument, and we can do one more thing. Since we are not using the function, we can ignore it by using an underscore. So what this underscore means is we simply want to ignore the value of function in our base case. Next, let us have a look at our recursive case. So let me again copy and paste. Here as usual, let me pattern match on our head and our tail. The next is our function. And since this is a tail recursive function, we have to call ourselves back each time. So first let me ignore the first value. I will come to this a little later. Now the next argument is for the function, and for each iteration we simply have to pass the function as it is. We don't have to do anything with it. Now the third is where we collect our accumulator. Now inside the accumulator, what do we want to do is we simply want to take this function and we want to apply this function on our head. Now remember that since this is an anonymous function, we can use the dot syntax. So we can say here first we want to take the function and use the dot syntax, and we want to apply this function on our head, and we simply want to append our accumulator at the back. Now let us come to the first argument. Now since we have used the head, the only thing left is to pass the tail, and that's it. Let me save the file and let us open up our IEX. Let us go inside our IEX and let me clear up everything, and let us try it out. So we can say tutorials.list.map, and we can say that our map is 1, 2 and 3, and the function that we want to pass is the same one. Let us take the element, and for each element let us simply multiply it by 2. Don't forget the end, and that's it. and we get the answer back. But as you can see, the order is not right. What has happened is we have reversed the list as well. So this 3 is right over here. So 3 multiplied by 2, it should be 6. But in our case, 6 is the first element, and 2 into 2, we have 4 over here. And for the first element is 1 into 2, and we have 2 right over here. But as you can see that this is not the right answer. We have reversed the order of our elements as well. So what we can do is, first we can call our tutorials.list.reverse, and inside this let us pass our map function. Let me just copy and paste it over here, and now we can see that we have the right answer 2, 4 and 6. But as you can see that this syntax can be confusing, so let me introduce you the pipeline operator. So let us paste the map function over here, and we can see that we simply want to take the output of this map function and we want to pipe that output inside the new function, and the new function is our tutorials.list.reverse. Now here we don't need to specify the arguments. What happens is the pipeline operator simply takes the output of the previous statement and it simply passes that output inside our function as the first argument. So let us press enter and let us see what's happening. So as expected, we get the right answer back, 2, 4 and 6. Let me clear it up. Let us do some more. So for example, if you want to reverse the same list, so we can invoke tutorials.list.reverse, and suppose in our case the list is 1, 2, 3 and 4. Now instead of using this syntax, what we can do is we can first take our elements. Here we can use the pipe operator. So we can say that I want you to take all of these elements and I want you to pass them to my tutorials.list.reverse. So what happens is we can use this pipeline operator in case if we have multiple transformations. So let us use the same example one more time. Here let us create an anonymous function called as double, and what we want to do is we simply want to take the element and we want to return that element multiplied by 2. And now let us see how we can use the pipeline operator. So for example, we have a list like this 1, 2, 3 and 4, and what we can do is we can take these elements and we can pipe these elements to our function of tutorials.list.map. Now remember that the function of map accepts two parameters, the elements and the function. Now here what happens is, since we are using the pipeline operator, these elements are passed automatically to the function of map, and the pipeline operator always passes these elements as the first argument. So since we have the first argument, we simply have to pass the second argument. So here we can say that we want to pass the anonymous function called as double, and for the accumulator we don't have to pass any value because the default value for the accumulator is an empty list. So let us see the output of this one. So we get the output of 8, 6, 4 and 2. Now what we can do is we can take the exact same expression and we can pipe the output of the map function to our reverse function. So we can use tutorials.list.reverse, and this time we get the expected answer as 2, 4, 6 and 8. Now instead of using the list.reverse, in fact we can use the inbuilt module. So if we go to the module of enum, so here we can say that we want to pipe the output into enum.reverse, and we get the exact same answer back. So instead of using our defined function, we can use the inbuilt function as well. So as you can see that this pipeline operator is very handy whenever we want to do multiple transformations. So let us go back to our function of map, and what we want to do is this accumulator has to be piped to our function of reverse, and that's it. Now if we open up our terminal, let us recompile tutorials.list. Let us clear up everything, and this time if I have a list of 1, 2, 3 and 4, and if I just pipe this list to tutorials.list.map, and let us pass an anonymous function. So we can say let us take that element and let us multiply that element by 3 this time, and that's it. We get the right output back. Now again, coming back to our code editor, either you can use this pipeline operator or you can use the conventional syntax. So you can simply call the function of reverse, pass the element of accumulator, and let me take out this one. Let us also see how to write the specifications for this function. So let us use the module attribute of specifications for the function of map. Now the first parameter elements is going to be a list, and the type can be of anything, so anything goes over here. The next is a function. Now in order to denote that this is a function, we can use brackets over here, and here we can say that this function accepts an input. The input can be of any type, then it transforms that value and it also gives back some kind of a value back. So this is how we can define the function type. The next one is for the accumulator, and again accumulator is going to be a list of any. Now the return type is also going to be our list of any. Well, that's it for this one, and I will catch you in the next video. Now let us see how we can concat, or how we can add two lists together. So first let me show you inside the terminal. So suppose we have one list like this, 1, 2 and 3, and we want to add one more list. Now in order to add or concat, we have to use the double plus, and the next list would be 4, 5 and 6, and here we get the combined list back. So let us see how we can write a concat function to do exactly this. Now in order to add or concat, we have two lists. So for example, the first list is 1, 2 and 3, and we have one more list 4, 5 and 6. So essentially what we want to do is we want to take the last element and we want to insert that last element at the head of the next list. But taking the last element is not efficient because we have to traverse through the entire list and then go to the last element. So what we can do is we can simply reverse the first list. So the first list becomes something like this, 3, 2 and 1. And for each iteration, we simply have to take out the head and insert it at the head position for our list number 2 as well. So for the first iteration, we insert 3. For the next iteration, we insert 2. And for the last one, we insert 1. And by the time we insert 1, this list becomes an empty list. So this is how we are going to implement our concat function. So let's define the function right over here. So we can say define concat. Now this function accepts two arguments. We can call the first list as our source. The second list can be our destination. Now for this function, we don't need an accumulator. The second list itself acts like an accumulator. So here what I'm going to do is I'm going to write an auxiliary function. So first let us write the function and then we can define it. So we can simply call the auxiliary function as concat underscore function. Now remember, as I just said a couple of minutes back, first we have to reverse this list, and we can do that right inside our function definition. So here we can say that let us take the source list and we simply want to pipe it to our function of reverse. The next is our destination list, and we want our destination list as it is. So now we can go ahead and define this auxiliary function. So here we can say that we want to create a function called as concat func. This accepts two parameters, the first list called as source, the second list called as destination. Now here as our base case, we can simply pattern match on our source. So in case the source is blank, at that time we simply want to return back our destination. The next, let us see how we can define the recursive case. So we can say we want to define concat one more time, and here we can simply pattern match on the first list. So for the first list, we can pattern match on the head, and for the tail, the second parameter is for our destination list. And let us see how we can define the logic for this one. Now for each iteration, we want to call ourselves back, right? Here first let us define the second parameter. So for each iteration, what we want to do is we simply want to take the head and we want to append our destination list to this one. Now the last thing to do is we simply have to pass the tail for our first argument. So let me open up my terminal, let me go inside my IEX and let me clear up everything. Now here we can say that we want to go to tutorials.list.concat. Now the first list would be 1, 2 and 3. The second list would be 4, 5 and 6. And that's it. We get back the desired output. The last thing to do is we simply want to add our type specification. So let me take out the comment. I don't need the comment. And here we can use the module attribute of specifications for our function of concat. The first parameter is a list and the elements are any. The next parameter is also a list and the elements are of any type, and this gives back a list and the types are any. Next, coming to our helper function of concat_func. Now this function is intended only for internal use. So what we can do is we can define the auxiliary function to be private. So here, instead of just writing def, we can write def and p. That means that this is going to be a private function. And that's it. Let's have a look at the last function inside our list. And this function is called as FlatMap. Now, to be frank, I was slightly confused. Should I include this function in this series or not? Then I thought, okay, why not? Let me add this one and let us see how it goes. So first, let me show you what do I mean by a flat map. So let us go back to our terminal, and here let us see the documentation for our enum module and the flat map function. So what this function does is it accepts an enum and it also accepts one function. Now flat map is all about the combination of your two functions. That is, it's a combination of your map and concat. And here we have one more example as well. So we get an input as a list. So during the first iteration, we get an item of A and we give back a list of A and A. But if you see right over here, we don't have a list of A, we don't have a separate list for B, and we don't have a separate list of C. And that's because we have flattened the entire list. So let us see how we can do this by using our recursive functions. Now you must be thinking, why are we implementing so many functions which are already there inside the standard library? So the answer is, I want you to really get comfortable with the recursion, and from the next video we will see how we can use all of the inbuilt modules. But for this last one, let us see how we can implement this functionality by using our tail recursive function. So let us go back to our code editor, and here let us create a function called as FlatMap. So we can say define my FlatMap. So this function accepts two parameters. So if we go back to the documentation, we can see that this accepts two parameters. The first argument is for the elements, the second argument is for the function. So let us do the same thing. Here we can say that the first argument is for the elements, the second argument is for a function. Now we also need one more argument for our accumulator, because what we want to do is we want to collect the output inside our accumulator. So here we can say that we also want to have an accumulator and we want to have the default value of an empty list as well. Now let me copy and paste. Now let us think of our base case. So the base case is very simple. In case the elements is a blank list, at that time we don't need this function. So either you can put an underscore over here, or you can simply replace the entire function with just an underscore. Both of them are valid syntax. And in this case, we simply want to return back the accumulator as it is. Now let us copy and paste one more time, and this is going to be our recursive case. Now in this case, we need our function as well. And for the first argument, let us pattern match on our head and our tail. And for each iteration, we want to call ourselves back. So let us call the flat map back. Now, as you know, the first argument should be our tail, because for each iteration, we want to take out the head. So the first argument becomes the tail. The second argument is we want to pass the function as it is. We don't want to change the function. Now let us see what we can pass as our third argument. Now if we go back to our documentation, it is clearly saying that this is a combination of our map and concat. So let's not use our brain and let's follow exactly what these guys are saying. So here what we want to do is we simply want to concat. And the first argument for our concat function is going to be our accumulator. And for the second function, we want to apply this anonymous function on the head. Now remember, since function is an anonymous function, we can invoke it by using the dot operator. So we can say function dot and let us pass head to this one. And that's it. We have implemented the flat map function. Now let me open up my terminal. Let us recompile the module of tutorials.list. Let me clear up the screen, and let's do one thing. Let us go over here and let me copy all of these things. Now here inside our terminal, we can say that from tutorials.list.flatmap, and let us pass the arguments. And now let us try and compare the output. So here we have the output, which is exactly the same as right over here. So that brings us to the end of this section for the list. Now what we have done for this section is we have implemented a lot of functions from the standard library by using tail recursion. From the next video, instead of writing all of these functions by hand, we will try and use the functions from the standard library. But for now, that's it, and I will catch you in the next one. Hi, and congratulations for making it so far. So till now, we have seen a lot of recursion. Specifically, we have seen a lot of tail recursion. Now, the whole idea of showing you so much of recursion was I wanted you to get used to the idea of recursion and how we can use functional programming. But moving forward, instead of writing all of the functions ourselves, we will use the functions from the standard library. Now, Elixir ships with a lot of inbuilt functions, and you can find these functions inside modules such as enum. Then we have separate module for your list and keyword list and so on. So that's what we will see. So the next section is all about your data transformations, how we can use all of these functions and how we can transform data to get our desired outputs. So I will catch you right in the next video. Till then, bye. Now let us see how we can start working with our structs and the inbuilt modules. So the first thing which I want to do is let us create a new folder inside our lib, and we can call that folder as structs. And inside of this folder, let me create one more file by the name of 7 wonders. Let me collapse my sidebar and let us see what we can do with this struct. The first thing, as usual, we need to define our module. So this would be our tutorials.structs.7wonders. So let us create a struct by using the keyword of def struct. Here we need to specify the fields for our struct. So we can say that the first field would be the name of the 7 wonders, and the second field would be the country of that 7 wonder. Now we can do one slight improvement. We can also initialize the values right over here, and instead of just passing a normal list, we can pass a keyword list. So here we can say that the default value of name should be a blank string, and the same thing happens for the country as well. So in case the argument is not given, we want to initialize the country to be a blank string. Now let us see how we can also define the type specifications for our struct. Now for defining the type of our struct, we have to use the keyword of type. So let's define a type right over here, and let us call the type as T. So this is more like your community convention. Your T stands just for your type. And here we can specify that we want to specify that type for our tutorials.structs.7wonders. Now remember that the struct always takes the name of the module, and in this case the name of our module is tutorials.structs.7wonders. So by default that's going to be the name of our struct. And since this is a struct, let us use the right syntax. So we need to put our % symbol over here and our curly brackets. So now we have a struct. Now what we can do is, typing such a long name can be boring, so we can simply alias this. So let's create an alias at the top. So we can say we simply want to create an alias, and here we can simply take out all of these things. Now inside the curly brackets, let us define the types for the various fields. So the first field inside our struct of 7 wonders is for the name, and here we can define the type to be of string. So we can say string.t, so the type of string. The next one we have for the country, and again the country is going to be of the type of string. So this is how you define the type specifications for your struct. Next, let us do one more thing. Let us create a list of all of the 7 wonders. So for this, let us create a simple function called as all. So this function does not take anything, and this returns your list. Now inside this list, let us initialize all of the 7 wonders. So we can say that the first 7 wonder would be Taj Mahal. So since I'm from India, the first one has to be Taj Mahal, and we can say the country is going to be India. And let me just copy and paste all of the remaining 6 wonders. So now we have a nice list of all of the 7 wonders of the world. Next, let us see how we can also write the type specifications for this new function. So here we can use the module attribute of our specifications, and we want to define the specifications for the function of all. Now since this function does not accept any parameters, you can use the brackets or you can skip them. And here we can also define the return type. Now the return type is a list and the elements are of the type of T. So right over here we have defined the type of T and we have specified the different parameters for our struct, and that's what we are referencing right over here. Let me put a separator line over here. Let's scroll a little bit down and let us see how we can start working with our 7 wonders. So here let us do one thing. Let us define a function called as print names. So what this function will do is it will accept all of the wonders and it will simply print out the names of the wonders. So for example, if we see we have different names, so we have the Taj Mahal, Petra, Christ the Redeemer and so on. So what I want you to do for this function is, so this function is going to accept this list right over here, and for the output we just want to see the names and that's it. So let us see how we can implement this function. Now this time, instead of writing functions ourselves, let us see how we can use the standard library. So let me open up my terminal, and here the first module that you would like to check is the module of enum. So what I can do is, let us call help and let us see what are the different functions inside the module of enum. So if I put a dot and if I press tab, and we can see that this inbuilt module has a lot of inbuilt functions. Now I want to see the documentation of a very specific function, and that is this one for each. So here let me call the help on enum.each. So this function of each accepts 2 parameters. The first parameter is for your enum and the second one is for the function. And we also have a sample implementation. So here we can see that the first parameter is a list and we have a simple function. So what's happening is, for each iteration, this function receives an element from the list. So for the first iteration, your X is the string of sum, and what this function is doing, it is simply printing it out. That's why we have the output of sum. For the second iteration, your X becomes example, and that is what is being printed out right over here. So let us see how we can use this inbuilt function for printing out all of the names for our 7 wonders. So let us go back to our code editor, and here what we can do is we can use the same function. We can say enum.each. Now our enum is going to be our list of our wonders. Next, let us define our function, and for the function, for each iteration we are going to receive 1 wonder from our list of wonders. So for each iteration, what's going to happen is we are going to receive a wonder and we have to do something with the wonder, and this is the end block for our function. Now since we just want to print the name of our wonder, we can actually pattern match right over here. Now we know that this wonder is going to be the struct of 7 wonders, and we can easily pattern match on our structs by using our map syntax. So let's do the pattern match right over here. So here we can see that for each iteration we want to pattern match, and we want to pattern match on the parameter of name, and we want to collect the name inside a variable called as name. And for each iteration we simply want to print it out, and let us put the variable of name right over here, and that's it. Let us open up our terminal. Let me go inside my IX. Now let me create an alias for our tutorials.structs.7wonders. Let me clear up everything, and here we can say that the list of all our wonders is our 7 wonders, and remember we have defined a function of all. So now we have all of the wonders. Let me clear up one more time, and next what we can do is we can again use the same module of 7 wonders, and let us print out the names. So this function takes 1 argument, and that is the list of all our wonders, and that's it. Now we can see that we have the right output and we get back just the names of all of our 7 wonders. Let us go back to the code editor and let us also define the type specification for this function. So here we can say that the specifications for our function of print names. So the first argument is the list of all of our wonders. So we can say that this is a list, and the type is the type of T that we have defined. Now since this function is not returning anything, we can say that this simply returns an atom of OK. Also, if you want, you can also use the pipeline operator. So what I can do, let me take this one out, let me put it on this line, and on the next line let me use the pipeline operator. So by default our list of wonders is being passed as the first argument for the function of enum.each. Let me save this one. Let me open up my terminal. Let me again recompile everything. Let us try to run the same function one more time. And as expected, we get the right answer back. Next, let us see how we can filter a single 7 vendor from our list. So here let us create a new function and let me name the function as filter by country. Now this function will accept two parameters. The first parameter is obviously the list of all our vendors, and the second one is the name of our country for which we want to filter for. So for example, if the country is India, then we should get back this single 7 vendor. So let us see how we can implement this filter function. Here let me add my do and end blocks and let me take this a little up. So again, let us go back to our terminal and let us see if we can find a filter function inside our standard library. So again, let me call the helper documentation from our module of enum and let us see if this module has a function of filter or not. So here it is, we have a function of filter. So let us see the documentation of this function. So this function of filter, this accepts two different parameters. The first is obviously our enum and second parameter is going to be a function. And here we have a sample implementation. So as we can see, the first element is a list and the second argument is going to be a function. Now if we read the documentation, it is saying that this function returns only those elements for which your function returns a truthy value. So let's see what's happening inside this example. So here they have a condition, and whenever this condition evaluates to true, only that value is returned. So here we have a list of 1, 2 and 3, and this condition is only satisfied for the element of 2, and that's why we get back a list along with a single element of 2. So let's see how we can use this inbuilt function for filtering by the name of our country. So here we can take the list of our vendors and then we can pipe this argument to our enum.filter. Now again, by default, the first argument of vendors would be passed and we simply need to pass the second argument for our function. This function receives a vendor for each iteration. So this is how it's going to look like. And here we need to specify a condition that will evaluate to a true. So here what we can do is we can again pattern match on this struct of 7 vendors. So let's do that thing. And this time we simply want to extract the name of the country. So let us pattern match on the field of country and let us collect the data inside a variable called as country name. Now next, coming to our truth condition, here we can say that we want to filter it out only when the country name is equal to the name of the country. So this parameter country is what is being passed to our function right over here. And this parameter of country name is what we are extracting by using our pattern match right over here. So let me save the file. Let us open up our terminal and let us recompile the module of 7 vendors. Next, what we can do is we can say we want to use 7 vendors dot filter by country. Let us pass all of the vendors. And next, let us pass India and let us see what output we are getting. And as expected, we can see that we are getting the right answer back. Let us try one more time and let us try with Mexico. And again, we are getting the right answer back. So again, let us go back right over here and let us write the type specifications. So the specifications for our filter by country. The first argument is the list of the type of 7 vendors. The second argument is of the type of string and the return type is the list, and this contains a single type. Well, that's it for this video. In the next video, we will continue with the different functions on our structs. So let us continue with our structs. And behind the scenes, what I've done is I have added a couple of functions and let us see how we can implement all of these functions. So the first function that you can see over here, so this function is also about filtering, and we simply want to filter out the 7 vendors for which the countries start with I. So let us see how we can do this one. Let me copy this one and let me paste it right over here. Let me take all of these things a little up. So in this case, our truth function will change and we simply want to compare the values and check if the name of the country starts with I or not. So let me take this one out, and this time we can rename the variable from country name to just country. And let us see how we can compare the first alphabet of our string with I. For this, let us use another module, and the name of the module is going to be string, and this module has a very convenient function of starts with. Now if I hover over the function definition, we can see that this function accepts two different parameters. So they have one example over here, Elixir and ELI. So in this case, Elixir starts with ELI, that's why we get the answer as true. So the first argument would be our country and the second argument would be I. So let me open up the terminal. Again, let me recompile our module of 7 wonders. Let me clear up everything. Now let's invoke the function. So we can say 7 wonders dot countries which start with I, and let us pass all of the wonders to this one. And as expected, we get 2 wonders back. So the first wonder is made in India, the second wonder is made in Italy. The next function is sort by country length. Oh, before moving on, let us also add the type specifications for this one. So the specifications are pretty simple. This wonders is the list of our type of T, and this also returns a list of type of T. Alright, so now let us go to this sort function. So this time what we want to do is we simply want to sort all of the wonders by the length of the country name. So let us see how we can do this one. So if I go back to my terminal and let's check out for enum.sort. So we have a convenient function of sort inside the module of enum, and as you can see, it has a lot of documentation, but I wanted to show you a couple of key parameters. So this is the function of sort, and this function accepts 2 parameters. The first is the enum and the second one is an sorter. Now this sorter argument can be of multiple types. So let us refer to the official specifications for this function and let us try and figure it out. So the first is obviously your elements, and now for the second argument of sorter, we can see that we can pass a multiple of arguments. So what this specification is saying that either we can pass a function and this function receives 2 elements and this function has to return back a boolean value, or we can choose to pass this arguments as well. Now let us see how we can work with this one. So this is a pretty simple function that we can pass to our enum.sort. So let us go back to our code editor. Let us again use the arguments of wonder and let us pipe this one to our enum.sort. Now here let us see how we can define the sorter function. So this is going to be your regular function. Now for each iteration, this function is going to receive 2 different wonders. So we can call them as X and Y. And next, for the body of the function, we can simply say that we want to check for the length of the string for the first one, and let's compare if this length is less than the length of the next wonder. So again, we can use the same function string.length and let us pass the variable of y this time. So what we have done is we have defined a function, and for each iteration this function receives 2 different wonders, and we are simply trying to compare the length of these wonders, and that's it. So let me save the file, let me open up my terminal and let me again recompile the module. Let's try to invoke this function 7 wonders dot sort by country length and let us pass all of our wonders. Oh, we are getting an error, and that's because here we are trying to find the length of the entire struct. I forgot to specify the parameter that we want to check for the length of the name of the country. The same thing goes for this struct as well. So we want to check for the length of this country. Now let me save the file, open up my terminal. Let me recompile one more time, clear up the screen, and let us try to invoke this function one more time. So this time, as you can see, we have a nice sorted list. So as you can see, now the list is sorted according to the length of the country name. So Peru, this is 4 characters long. So this is the first one. Next is China, this is 5 characters. Again, then we have Italy and India, then we have Brazil and so on. So as you can see, we have a nicely sorted list. So now let us go back and let us see what we want to do for the next one. So for the next function of name country list, so this function accepts our wonders and I want an output like this. So the output has to be the list. and inside the list we want another list. The first element has to be the name of the 7 vendor and the second name has to be the country. So let us see how we can do this one. So let me take out the comment. I don't need the comments. And before I show this one, let me take you back to my terminal and let me clear up all of these things. And this time let us check out the documentation for enum.reduce. Now this function of reduce, this is a very powerful function, and in fact you can implement all of the functions inside the module of enum by just using this simple function. So first let us see the function signature. So this function of reduce accepts 3 parameters. The first argument is for your enum, the second argument is for your accumulator, and the third argument is for your function. And we have one sample example right over here. So the first argument is a list, the second argument is for the accumulator, and the third argument that you can see over here, this is for a function. Now this function receives an element for each iteration, and this function also receives the accumulator. So for the first iteration, since the accumulator is 0, this would be 0, and for the first iteration our x would be 1. Now what happens with this function is that the result is passed as the accumulator for the next iteration. So you can read the documentation over here. So this is what is happening. So for the second iteration, whatever this evaluates to, so this value will become your new accumulator. So let us see this reduce function in action. So let us go back to our code editor. Now let us see how we can work with our reduce function. So we can say enum.reduce. The first argument is for our vendors. The second argument is going to be our accumulator. So as our initial accumulator, let us just pass an empty list. And the third one is going to be a function. Now let me do one thing. Let me take this one out and let us pipe into our enum.reduce. Now for each iteration, this function is going to receive 2 parameters. The first parameter is going to be our vendor and the second parameter is going to be our accumulator. So initially the accumulator is going to be a blank list, and for each iteration, what do we want to do? We simply want to create a list. Inside this list, we need another list, and inside this inner list, the first argument would be the name of the vendor and second one would be the country of the vendor. So here we can say that from vendor, I simply want you to take the name, and the second argument is going to be the country for this one. And after this, we simply want to append our accumulator back. And that's it. Let me save my file. Let me open up my terminal. Let me recompile the module and let me clear up the screen. Let us invoke this function. So we can say 7 vendors dot name country list, and let us pass all of the vendors, and as expected we get the answer back. So here we can see the first argument is going to be the name of the vendor followed by the name of the country. Now just to give you some more practice, let us try and use this reduce function one more time. So for this function right over here, country name keyword list, so this is what I want you to do. So this function is going to accept our vendors, and this is the output that I'm expecting. So we want to have a list, and inside the list we want to create our keyword list. So as you can see, this is going to be an atom and this is going to be the value. So let me just copy all of these things. Let me copy this one and let me paste it right over here. I don't need the comment. Let me take it out and let us see how we can work with this function. Now here what I want to do is, we don't want an inner list. Instead what we want is a tuple. So let me change this from a list to a tuple. So let me explain why do I want a tuple. So let me open up my terminal. So for example, if we have a keyword list like this, A and 1, so this keyword list is actually saved as a list of our tuples. So in case if I have to pattern match, so on the left hand side, let us create one more list. And here if I create a tuple, the first element is going to be the item of A, the second element is going to be the value of 1. So let us see if this is a pattern match or not. So yes, this is a pattern match. So what's happening is this keyword list is saved in this format. I think I have covered this while explaining keyword list as well. So this is a small recap for you. So this is the same logic that we are using over here. So that's why we want to have a tuple and not an inner list. Now the first element has to be an atom. So what I can do is let me wrap this inside, and we can convert this string to an atom by using our string dot to atom. And that's it. Now let me open up my terminal. Again, let us recompile our module and let me clear up the screen, and let us try to invoke this function 7wonders dot country name keyword list, and let us pass the arguments of all wonders. So this time, as you can see, that the first argument is going to be our atom and the value is going to be the name of the country. Now before going to the last function, I wanted to show you a couple of things. So again, let me open up my terminal. Let me clear up all of those things. So in case if you want to make a list of just the names of the wonders, we can use multiple modules. So let me show you one more alternate method. So we can say enum.map, and the first argument is going to be our argument of all of our wonders. And what we can do is we can simply invoke a function. So this function receives a wonder each time, and what we want to do is we simply want to return the name of the wonder, and we get back a list of all of the names. Now what we can do is Elixir actually offers a shorthand syntax. So what we can do is we can change this function to a shorthand syntax. So we can say that we want to send a reference to an anonymous function, and this function is going to receive a parameter. So we can say for the first parameter, we simply want to return the name back, and that's it. So this is the shorthand syntax, and we get the exact same answer back. So if you're comfortable, you can use the shorthand syntax, or else you can use the regular syntax. Now for the last part of this video, I wanted to show you the for comprehensions inside Elixir. We can get the exact same output by using the for comprehensions. So we can say for, and here we can say that for each iteration, we simply want to pattern match, and we want to extract the name inside a variable of name, and we want to extract this from our list of all of the wonders. And for each iteration, I simply want to return back the name of the wonder, and that's it. We get back the exact same result. Now this syntax is slightly weird. So what we are trying to do is we are trying to say that for each element out of this enum, we want to pattern match, and we want to pattern match on name, and for each iteration we simply want to return the name back. So you can use any of the syntax with which you feel more comfortable. Now let me just copy this one and let me go back to my code editor. So for this one, let us use the for comprehension. Let me paste it right over here. We also need to pass an argument to the function. So this argument becomes for our wonders, and this also has to change to wonders. Now let me open up my terminal. Let me recompile the module, and let me clear up this one, and let us try to run this one. So 7wonders dot all names. Oh, I forgot to pass the arguments. So all names, and the argument is all wonders, and we get back the exact same answer. Well, that's it for this video, and I will catch you in the next one. Let us have some more practice with our structs. So what I've done is behind the scenes, I've created a new file called as expense, and let us get started with this one. So first, as usual, let us create our module, and let me call this module as tutorials.structs.expense. Now just imagine that we are creating an application to manage our expenses. So let us define a struct to hold our expenses. So we can say that we want to define a struct, and since this struct is going to have multiple fields, let me take them on different lines. So the first field would be for the title of our expense, and we can initialize the title to be a blank string. The second one would be the date of our expense. Initially we can keep it as nil. The next one would be the amount of our expense, and let us initialize the amount to be 0. The next one can be the store from which we did the purchase, and let us initialize the store to be also a blank string. Now let us also define the types for our struct. So first let me create an alias. So I want to create an alias for my tutorials.structs.expense, and here let us define the type for this one. So we can say the type of T for our struct of our expense. The first field for title, so this is going to be of the type of string. The second one is date. For this we can specify that the type is going to be of the type of date, or it can also be nil. The next one is for our amount, so this is going to be a number, and next one is for the store. This is going to be of the type of string. So now we have the type specification in place. Now let us see how we can work with our expense struct. First, let me create a couple of sample expenses. So let me define a function called as sample. So this function will simply return a couple of our expenses. Let us create an expense right over here. So we can say that we want to create an expense. Now for the title, we can say that we got some grocery. The next field is for the date. Now the type of this has to be a date. So for this, let me go to my terminal, and here let me show you how we can create a date. So Elixir has a module for date, so we can use that module. So let me show you. So let us check the documentation for that module. So we can say we want to see the helper documentation of date.new. So as you can see, this function of new, this accepts a year, month and day. So let us try this one. So let me clear up everything. So here we can create a new date. So we can say date.new. The first argument was for the year, so we can say 2023. The next argument was for the month, so we can say for April, and for the day we can say the 1st of April, and that's it. We get back a date, but as you can see, we get back a tuple back. So let us pattern match and let us extract the date. So what we can do is just on the left hand side, let me pattern match. So the first element would be the item of OK, and let us create a variable for the date, and let us just check out the contents of date. So that's it, we have a new date. Now this syntax that you can see over here, this sigil and D, this also denotes a date, and in fact we can use this syntax to create a new date. We don't have to always invoke the function of date.new. So what we can do is we can create a sigil. So this is the sign for sigil, and let us create a sigil for our date, and here we can say that the year has to be 2023, the month can be March, and the date can be 31st of March, and that's it. We have a new date in place. So now let us go back to the struct and let us create a date right over here. So let me use the sigil over here. So I can say I want to create a date, and suppose my year is 2023, my month can be September, and suppose the date is 12th of September. Next is the amount. Suppose the amount is 18.99, and let's say the store is going to be Metro. So now we have created an expense. Now let me just copy and paste a bunch of more expenses. So that's it. Let me open up my terminal and let me clear up all of these things. Let us go inside the IEX and let me create an alias for my tutorials.structs.expense, and let me clear this one more time. Let us create a variable for our sample expenses. So we can say that my sample expenses is equal to my expenses dot the function of sample. So now we have a bunch of samples. So now let us go back to the code editor and let us see what we can do with our expenses. Oh, before that, let us add the type specifications for this one. So here we can specify that the specifications for our sample, so this does not accept anything, and this returns a list of the type of t that we have just defined. Next, let us write a function to get the total amount that we have spent. So we can say that the function is going to be our total, and this function accepts our expenses, and let's define the body of this function. So this expenses would be the list of all our expenses. For example, if we get this expenses, then we simply want to add all of the amounts together and we want to give back the total amount. So let us see how we can do this one. Let me take all of these things a little up. Now you can solve this by using multiple methods, but I'm going to use the enum.reduce. So first let me take the expenses and let me pipe the expenses into enum.reduce. Now for this function of reduce, let us define an accumulator. So let's say that my initial accumulator is 0. The next one comes the function, Now for each iteration, this function receives two parameters. The first is going to be the expense, the second is going to be the accumulator. And for each iteration, I simply want to go to my expense, take the amount and add that amount to my accumulator. So that's it. Now let us go back to our terminal. Let us recompile our expense. Let me clear up everything. And now let us invoke this function. So we can say expense dot, let us get the total for our sample. And that's it. We get the answer as 1025.62. Let us go back and let us also write the type specifications for this one. So this function of total, this accepts a list of the type of t and this returns a number. So if you hover over number, you can see that your number can either be an integer or a float. Next, let us write a function to sort our expenses by the date. So we can say that we want to define a function and this function accepts our list of expenses. And now let us see how we can sort our list. So in the last video, we have seen how to sort a list, but this time we want to sort by date. So let me take you back to my terminal. So let us see the documentation for our enum.sort. So last time we had used sort, but we have one more function by the name of sort and by. Now let us see the documentation for this one. Let me slightly scroll up and here they have an example in which they are using date. So for example, they have a list of different maps and each of the map has a field for the date. And this is how they are sorting the date. So the first argument is obviously your enum. For the second argument, they are using a shorthand syntax. You can use your regular function. And what they are trying to say is for each iteration, they want to sort by the birthday. So let us use this shorthand syntax and let us see how we can sort our date. So here we can say that first let me take all of my expenses, then let me pipe all of these things into my enum.sort by, and let us use the shorthand syntax. So we can say I want to give a reference to an anonymous function and for each iteration I want to sort by the date. Let us open up our terminal. Let us recompile our expense. Let me clear up the screen and here we can say that expense dot sort by date and let us pass the list of our samples and let us see what's happening. So here you can see that the dates are sorted. The last one is for 30th of October. The earlier one is 18th of October. So this one is for September and this one is for July. So we have a nicely sorted list in ascending order. In case if you want to change the order, you can refer the documentation. So here they are saying that in case if you want descending, then you can add this parameters as well. Let us go back. Let us write the specifications for this one. So sort by date. So this accepts the list of the type of t and this also returns the same list of the type of t. Next, let us see how we can add an expense to our list of expenses. So let's define a function called as add expense. So this accepts one single expense and let us write the body of our function. Now this is going to be a very simple function. So we simply have to take the expense and we simply want to append this expense to our existing list of samples. Now for this one, I wanted to show you one small trick. So in case if you want to enforce that this expense has to be of the type of the struct of expense, then what we can do is we can simply use a pattern match right over here. So here we can say that we want to have a pattern match for our struct of expense. So essentially what we are doing is we want to enforce that the type of this parameter has to be of the type of our struct. Let us also add the specifications for this one. So we can say that our add expense, this accepts the type of t and this returns the list and the list has of the type of t as well. Now let me open up my terminal. Let us also recompile the model for our expense. Let me clear up everything. Now first let me create an expense. So let us create a variable for our expense and let us initialize our struct. So here we want to say that our expense, suppose we want to buy some coffee and let's say the date would be for the 1st of April. So we can use the sigil and we can say we want to sigil for the date and the date is going to be 2023. The month is April. The date is the 1st of April. Let's say the amount for this one is going to be $10 and let's say we buy this from Metro. So now we have one expense with us. Now let us try adding this expense. So we can say expense dot add our expense, and let us pass the newly created expense, and we get back an answer. So let us see if we have coffee in this list or not. So yes, as we can see, the first item is the coffee. So we have added our expense inside the list. So let us go back and let us see what else we can do. Next, let us see how we can update a single entry inside our list of expenses. So for example, let's see how we can update an amount for a particular expense. So let us create a function and let us call the function as update amount. Now this function will take two parameters. The first parameter is the title for our expense, and the second can be the amount, so the updated amount. And let us see how we can write the body for this one. So for example, what I want to do is, suppose we are buying grocery and we want to update the amount from $18.99 to say $20. So let's see how we can do that. So for updating the amount, we have to do a couple of things. So the first thing is we need to filter out the expense that we want to update. The second step is we want to create a new expense with the updated amount, because remember, all of the data types in Elixir are immutable. The third is we simply want to add this expense to our samples and we want to take out the old entry. So let us see how we can do these things. So the first step is to filter the exact expense with the given title. So we can say we want to use enum.filter. The first argument would be for our sample expenses. So we can just pass the function of sample over here. Next, we have to define a function right over here. So let me use the function and end. And for each iteration, this function receives one single expense. So let us pattern match on the expense title. So here we can say that we want to extract the title and we want to capture the title in a new variable, and let us name the variable as expense title. And for each iteration, we simply have to check if the expense title is equal to the given title. So this title comes from the function definition, which is right over here. And we also need to capture this expense. So if you just hover on filter, so here we can see that the result is a list. So let us pattern match and let us extract that expense. So on the left, let us pattern match over here. And let us create a new list and let us create a variable called as item. So this item will hold the expense that we have just filtered. The next step is to create a new expense. So we can say that we want to create a variable for the new item, and let us create a new expense by updating this item. So we can say for my struct of item, I want to update the amount by the new amount. So this amount comes from the function definition right over here. So now we have the new amount. The last thing is we simply have to append the new item to our list of samples. But before we can append, we also need to remove the old item from our list of samples. But we can do all of these things in one place in a single statement. So let me show you how we can do this. So here we can say that we want to append the new item to our list of our samples. But before we can append, we also need to remove the old entry. So what we can do is we can simply take the output of sample and pipe this into a new function, and we can say list.delete and let me pass the old item to this function, and that's it. So what's going to happen is first we are going to remove the entry from the list of samples, and after that the new item is going to be appended. Now let me open up the terminal, and as usual let us again recompile our expense. Let me clear up the screen and let us try to invoke this function expense.update amount. Now for example, we want to update the amount of our grocery from $18.99 to say $30, and let us check if we have updated the amount or not. So yes, so this is the entry for grocery and the new amount is 30. So let us go back. So till now we have seen a lot of different ways in which we can work with our structs. We have seen how to work with recursion, and we have also seen how to work with the inbuilt modules. Now for the last thing in this video, I wanted to show you the with statements. So for example, what happens, we may have to deal with multiple conditions. So for example, you are writing a web application and you want to have the functionality for login. Now in order to log in a user, we have to satisfy a multiple of different conditions. For example, first we need to authenticate, and then we also need to verify the password and so on. So basically what we want to do is, in order to log in, we have to satisfy a multiple of conditions, and you can satisfy multiple conditions by using the with syntax. So let me show you first, and it will be easy for you to understand. So the first thing is, let us create a dummy database for our users, and we can do that by writing our own custom module attributes. So here we can say that we want to define a module attribute by the name of users, and let us assign a list of different users. So what we have done is, so this is a module attribute and we have assigned a list of different users for this module attribute. So what happens is, we can use these users as a constant throughout our module. Next, let us write some dummy functions to authenticate and verify password. So here I can say that I want to define a function to authenticate, and this function will accept a user. And here what we can do is, we can use something which is called as a function guard. So here we can say that when the user is in my list of our users, only at that time I want to return a tuple, and the first element would be okay and the message would be authorized. So this syntax that you can see over here, this is called as guards. So in Elixir we can use different kinds of guards. So you will understand guards as and when you learn more of Elixir. But for now, let us just go with the flow. Next, let us create one more functional definition for our authenticate. So in case we don't have the user inside our database, so at that time we want to return a tuple. The first element would be error, and we can send back a message called as unauthorized. Next, let us create some dummy functions for verify password as well. So you can say we want to define verify password. Now this function will accept two parameters. The first is going to be the user and the second is going to be the password. And here also we can use the function guard. So we can say, in case the user is inside our database of users, only at that time I want to return back a tuple. The first element is going to be okay, and then we can pass the message as password verified. Now in case the username and the password does not match, so for this one let us create one more clause. So this, I don't need a guard for this one, and this has to be error, and let us pass the message as wrong password. And this case, since we are not doing anything with the password, let me use an underscore. And here also we are not doing anything with the user and the password. Okay, so now we have the basic framework in place. Now let us create a function for login. So we can say define login. Now this function accepts the user and also a password. Now let me take all of these things a little up. Now in order to log in a user, we have to satisfy a couple of different conditions. The first condition is, first we have to authenticate, and then we also have to verify the password. So let us see how we can use the with syntax. So first let me write the with block over here. So with do, and we can also write the else block over here. Now let's see how we can define the body of our with. So in order to log in, first we need to authenticate and we also need to verify at the same time. Now here let us call the function of authenticate and let us pass the user. Now we have to say that we have to satisfy this condition, and we can specify that by using an arrow syntax over here, and we can specify that in case we get a specific output, only then the user can be authenticated. And here we can specify that in case the first element is the atom of OK, and then we get some kind of a message back, only in that case the user would be authenticated. Now this is the first case of authenticate, but we also need to check if we can verify the password or not. So here let us call the function of verify password, let us pass the user, and let us also pass the password. Now we can say that this function of verify password also has to satisfy a couple of different conditions. So let me just copy this one from here and let me paste it right over here. So in case this function also succeeds and we get back a tuple with OK, and suppose the second one is for the message, let me put an underscore over here since we are not doing anything with the variable. So now what we are trying to do is, we are trying to check for two different conditions, authenticate and verify. And in case we satisfy both of these functions, then we can say that we want to return back a message. So the first would be the atom of OK, and then let's create a string. So we can say the user logged in successfully. But in case the function of authenticate or verify password fails, so in that case we'll go to the else block Now here we can pattern match on multiple conditions in case we get a tuple back and the first element is the atom of error, the second could be some kind of a message. So at that time we simply want to return back the same thing. So we want to return back the tuple of error and the message back. But in case we get some other error, so we can specify that by using the underscore. So in all other cases we simply want to return back an atom saying that this is an unauthorized operation. Oh, I forgot to put a comma over here. So this is how your with block looks like. So let me open up my terminal and let us see this thing in action. So let me recompile my module of expense. Let me clear the screen. And here we can say that from expense dot login. And first let us pass a user which is there inside our database. For example, we have the user of Louis inside our database. So let us pass the argument of Louis. And for the password, it does not matter because we are not doing anything with the password. And let us see what kind of output we are getting. So yes, we get back the message saying that Louis logged in successfully. Let's try this one more time with the user who does not exist. So let me change the spelling, and this time we get back the message as error unauthorized. So this was all about using the with syntax with our Elixir. Well, that's it for this video, and I will catch you in the next one. Hi, and welcome to the last section of our entire series. Now this last part or the last section is all about building a statistics library in Elixir. Now don't worry about the word or statistics. There is nothing big about statistics. As long as you know your basic mathematics like addition, subtraction, division and so on, you would be absolutely fine. You don't have to worry. Now I also wanted to discuss about a couple of things regarding functional programming. My first question is, do you have a hard time understanding functional programming? If your answer is yes, then don't worry, you are on the right track. Now what I mean to say is, our brains are so much used to the object-oriented programming paradigms or the imperative programming paradigms that it takes some time for you to understand about your data immutability and recursion. So don't worry, the only thing that you need is more practice. And the intent behind creating one more project is to give you more practice, isn't it? So don't worry, and this is going to be a very nice project. I will show you how we can slightly architect our code in a much better way, how we can create a different public API, how we can separate our internal implementation from the public API and so on. So overall this is going to be a very nice project. So hang on with me and I will catch you right in the next video. Till then, bye. So let's get started with our statistics project. But before that, I would like you to meet my friend Louis. Now Louis stays in Toronto and he owns a candies store. And Louis is going to help us to learn more about statistics. The first topic that we want to learn is called as central tendency. So central tendency is like a big chapter, but don't worry, I will make it very simple for you. The first thing that we want to study is how we can calculate a mean. Now mean is nothing, it's just a glorified word for average. So let us try and study a little bit more about these concepts. Now since Louis stays in Toronto, Louis wants to count the number of cars in Toronto. So this kind of data is called as your population data. Now this kind of data is called as population because our entire scope of data is just Toronto, right? We only want to count the number of cars which are there in Toronto. So this number of cars is going to be a finite number, and our scope or our range of data is limited just to Toronto. That's why this kind of data is called as your population data. Now let us see next what's going to happen. So next, Louis wants to count the number of cars in Toronto, but this time the data is different. Louis wants to count the number of cars in Toronto out of all of the cars in Canada. So this time what is happening is the number of cars in Toronto becomes your sample data. Now the reason why this data becomes sample data is we are taking a small subset of cars in Toronto from a bigger set of data, which is all of the cars in Canada. So all of the cars in Canada is your population, And since we are taking a small subset of cars just in Toronto, that's why this kind of data becomes your sample data. So let us have a look at one more example. For example, Lewis wants to calculate the average height of people in his house. So for example, if there are 4 people staying in his house, then that data becomes the population data. Now what's happening in this case is the number of people are just limited to the house of Lewis. And that's why the data is your population data, and we are trying to calculate the average height. That's why we simply have to calculate the population mean for this kind of data. The next is Lewis wants to calculate the average height of people in Toronto out of all of the people in Canada. Now what's happening in this case, all of the people in Canada, this data is your population data, and what we are targeting is we are targeting just the people who stay in Toronto. So this data is your sample data. That's why this average is going to be your sample mean, right? Let's have a look at one more example. Now Lewis owns a candy store in Toronto, and Lewis wants to calculate the average number of candies sold in 3 hours. Now what kind of a data would this be? Would this be a population data or would this be a sample data? The answer is this is going to be a population data, because our scope is just limited to 3 hours. And since this is a population data, we would be calculating the population mean. So for example, these are the different candies which are sold by Lewis. In the first hour, Lewis could sell 10 candies. For the second hour, Lewis sold 20 candies. And for the third hour, Lewis sold 30 candies. So let us see how we can calculate the mean for this kind of a data. So we have to just add all of the candies together. So that's what we are doing right over here. And then we simply have to divide by 3. So we get the answer as 20 candies for an hour. That means Lewis was able to sell on an average 20 candies per hour for the first 3 hours. Now let us have a look at one more example. Now this time Lewis wants to calculate the average candies sold in the first 3 hours out of the entire day. Now in this case, the full day would be your population data. And since we are just limited to the first 3 hours out of the full day, that means this is going to be our sample data, which means we have to calculate the sample mean. Now these are the different candies which are sold by Lewis throughout 8 hours in the day. So for the first hour, he sold 10 candies, for the second hour, 20 candies, for the third hour, 30 candies, and so on. So let us see how we can calculate the mean in this case. So again, everything remains the same. For the first 3 hours, we have the same figures. So 10 candies for the first hour, 20 for the second, 30 for the next. So that's why we have 10 plus 20 plus 30. And the number of hours for which we are calculating is 3. That's why we have 3 over here. And again, this evaluates to 20. That means for the first 3 hours in the entire day, Lewis was able to sell 20 candies in an hour. So you can see that the formula for the mean remains the same. So what's the difference? The difference is in perspective. Sample data is different and population data is different. So keep this perspective in your mind. And let us see how we can code this population and sample mean right in the next video. Let us get started with our statistics project. So let me open up my terminal and let's create a new mix project. So let me go inside my folder of Functional Programming with Elixir, and then let me go inside my folder of code, and right over here I want to create a new project. So I can say mix new stats, and let me open up the folder in a new window. So this is going to be our new statistics project. So let us see how we can implement our population and sample mean functionality. So the first thing is inside the folder of lib, let me create a new folder and let me call that folder as central tendency. Now inside this folder, let us create another file. So let me create a file, and this is going to be for calculating our population and sample mean. Let me collapse my sidebar, and first let us define a module. So this is going to be stats.centralTendency.mean. So here first let us see how we can calculate our population mean. Now the formula for calculating the population mean is very simple. We simply have to take the sum and we have to divide that sum with our count. Now in terms of statistics, this sum is also called as sigma. So let us see how we can calculate our population mean first. So let's define a function called as population mean. This function accepts a list of our numbers, so we can call the argument as numbers, and let us see how we can define the body for this function. But before we can define the body, here we need to do a lot of validation. The first validation that we need to do is we need to check if this numbers is actually a list or not. So for this we are going to use a guard. So let us go to the official documentation and let us try and see if we can find the right guard or not. So inside the module of kernel, we have a section for guards. So let us check if we can find the guard for list or not. So if I scroll a little bit down, here we have one guard, and this guard is right over here, is list. So let us see how we can use this guard in our function. So here what we can say that we want to have a guard saying that is list, and let us pass the variable of numbers. So basically what we want to do is we want to run this function only when this numbers is a list. Now we have validated that this numbers is a list. But what happens if this numbers is not a list, or in case the numbers is an empty list? So let's define one more function overload on the top. So here we can define that we want to define the same function population mean, and in case if we get a blank list, then at that time return back a blank list. Now we can either return back a blank list or we can also return some kind of an error. So for example, if you want to return some kind of an error, so we can return back a tuple and we can say that this is going to be an error, and we can also return back a message saying that invalid data type. So it's up to you. If you want, you can return back a blank list or you can return back an error tuple. So this is just for your reference. So now let us see how we can define the actual body for our population mean. So here we need to do two things. First, we need to find out the sum or the sigma, and then we have to divide by the count. But before we do all of these things, we need to do one more validation. So till now what we have validated is that this numbers is just a list. But we also need to validate that this is a list of numbers. So let us see how we can validate this one. So here let us create a pipeline. So here we can say that first I want you to take the numbers, and then I want you to pipe this numbers inside a function, and we can call that function as validate our number list. So we have not defined this function, but let's define it right over here. So let me just copy this one and let us define a function right over here. So validate our numbers list, this accept our list of numbers, and let us see how we can define the body for this one. Now for this function, let us return back a tuple. The first condition would be either true or false. The second condition would be the numbers. So in case if this list is not a list of numbers, we will send back false. But in case this is a valid list of numbers, then we will send back a true right over here. So let us see how we can do this thing. Unfortunately, it's very simple. So here let us use the inbuilt module of enum, and I want to use the function of all. Now this all takes two arguments. The first is going to be our enum. So let us pass the enum of our numbers, and this also takes a function. So let us define a function right over here. Now what happens for each iteration, we are going to receive an element from our list of numbers, and we simply have to check if that element is a number or not. So here we can use an inbuilt function called as isNumber, and let us pass the element to this one. And that's it. We have defined a function to validate all our numbers as well. Let us also write the type specification for this function. So here we can say that the specs for validate number list. So this receives a list of our numbers, and this function returns a tuple. The first is going to be our boolean, the second element is our list of numbers. Let us go back to our function of population mean. So now we have all of the validation in place. Now this function returns back a tuple. So what we can do is we can simply take that tuple and we can pipe the output in yet another function. So let us call the new function as calculate population mean. So we have not yet defined this function, but let's define it right over here. So here we can say that define calculate population mean, and let us write the do and the end blocks. Now this function of calculate population mean receives a tuple, right? The first is our condition, the second one is our list of numbers. Now this condition can either be true or it can be false. So suppose we have a true condition, then we can have a pattern match right over here. But in case if it is false, then we can create yet another clause. So let me just copy and paste this one. So here I can say that in case the argument is false and we don't have to do anything with numbers, so let me replace numbers with my underscore. In case the first argument is false, that means the validation has failed. So here we can again send the same tuple error. So let me copy this one and let me paste it right over here. Now let us see how we can calculate the population mean in case the first argument is true. Now here the formula is very simple. First we have to take the numbers. Next we have to calculate the sum, and we can calculate the sum by using an inbuilt function. So we can say enum.sum. The next one is we simply have to divide the sum with the count. So for this, let us define one more function and let us call that function as mean. So this function is going to receive two arguments. The first argument would be for the sigma, which comes from this one. The second argument would be for the count, and we can pass the second argument right over here. So we can say enum.count and let us pass the list of numbers. Now let us create this function right over here. So we can say define mean. The first argument is for the sigma, the second argument is for the count, and for this one the implementation is very easy. We simply have to divide the sigma with the count, and that's it. We have implemented population mean. But we can do a lot of improvements. So as you can see, we have some repetition. We have this tuple of error here as well as on the top as well. Let me also put some separator lines for our convenience. So this is going to be a separate thing, and calculation for the population mean is going to be a separate section, and one for this one as well. So now let us go to the top and let us see how we can improve our code. So now the first thing is we have this error tuple twice. So let's create a separate module for errors. So let me open up my sidebar, and inside the directory of lib, let me create a new module called as errors, and let us define the module as stats.errors. Let us define a function over here. So we can say define invalid data types, and we simply want to return back the tuple. So let me go back to the file of mean and let me just copy this line. Let us go back to our errors file and let me paste it right over here. Now let us go back to this file. Let me collapse my sidebar, and now what we can do is we can create an alias on the top. So we can say that let us create an alias for our stats.errors, and we can replace this line with errors.invalid data type, and we can do the same thing right over here. So let me take out this line and we can say that errors.invalid data type. Now I want to do one more thing. I want to take out this function of validate into yet another module, and this is because I simply know that we would require this validation function for our future implementation as well. So inside lib, let us create one more file for validators. Again, let us define the module, and the module name has to be stats.validators. Let us go back to this file. I simply want to cut everything out. So let me take it out. Let us go to our file of validators and let me paste it right over here. Now for this one, we can do one slight validation since we have taken this file inside another module. So here we can do one small validation as well. So let's define a guard over here. So when is list for our numbers, and in case if this validation fails, then let us create one more clause right over here. So here we can simply ignore the argument and we can simply return back an error. So let me again create an alias for the error right over here. So let's create an alias for our stats.errors and let us return an error right over here. So here we can say that errors.invalid data type. Now the specification for this one is going to change. So this function of invalid data type, this returns a tuple. Let us define a specification for this one as well. So let us go to errors, and here we can say that the specification for our function of invalid data type. So this function does not accept anything, and this simply return backs an atom, and the next argument is of the type of string. So let me copy all of these things. Let us go back to our file of validators. So now what's happening is, in case if this number is a list of numbers, we send back a tuple, but in case the validation fails, then we simply send back an error, and the format for the error is we have an atom and we also have a message, right? The next thing is, since we have taken this function in a different module, let us go back to our module of mean and let us create an alias on the top. So here we can say that we want to alias yet another module. So we can say that we want to alias stats.validators. Now what we are doing is we are importing errors and validators from the same module of stats. So we can create an alias on the same line. Let me show you how. So we just have to wrap this inside our curly brackets, and we can say that we also want to create an alias for validators as well. Now right over here on line number 10, this function is inside our module of validators. So validators.validate numbers list. Let me take out these lines. Let me open up my terminal and we can go inside our IEX. Let us create an alias for stats.centralTendency.mean. Let me clear up everything and let us call our population mean. So we can say population mean and let us pass 10, 20 and 30. And as expected, we get back the answer as 20. Now let us pass an empty list and see what's happening. So in this case, we are getting back an error saying that error invalid data type. Now watch what happens if we pass some other argument. For example, if we pass A, B and C. So in this case, we get an error saying that no function clause matching. And this is because we have not defined a catch-all clause for this function of population mean. So let us define one clause right over here. So here we can say that define population mean, and in this case we simply want to ignore the argument and we simply want to return back our errors dot invalid data type. Let me open up the terminal and let us recompile our module of mean. Let me clear up everything and let us try the same statement one more time. So this time we get a nice error saying that error invalid data type. So this is how we can create population mean. But we are not yet done. We also need to implement the sample mean. But luckily the formula for sample mean and population mean is the same. So let us very quickly implement our sample mean as well. Let me take out all of the comments. I don't need the comments. Let me paste the separator line on top. Now here let me again copy this separator line and let us create one more function for sample mean right over here. So here we can say that we want to define a function for our sample mean. Now this function accepts a list of numbers and we simply have to call our population mean and pass our list of numbers. So that's it. Now we have the function for sample mean and population mean as well. Let us also define the specifications for this function. So here we can say that the specifications for our population mean. Now this function receives a list of numbers and this function is going to return back a number or it is going to return back an error. Now the type of our error is like this. The first element is the atom and the second element is of the type of string. Let me copy this specification for our sample mean as well. Let me paste it right over here and let me change the name from population to sample. Next we can do a couple of more improvements for our code. Now if you see this function of calculate population mean and this function of mean, so these functions are just our private functions. So let us declare them as private. So this becomes our def of p and this also becomes our private function. The same thing happens for our mean as well. This also becomes our private function. Now let me open up the terminal. Let us try and recompile this one more time. Let me clear up everything and let us try to invoke the same function one more time. let us pass the list of 10, 20 and 30. So this is for the population mean, and let us try the same thing for our sample mean as well. So let me replace this with sample mean and we get the same answer back. Now what's happening is every time we have to create an alias, but instead what we can do is we can separate our public API from our private API. So if I open up my sidebar, we have a module for stats.ex, and as you can see that this file is not doing anything. So what we want to do is we want to make this stats file as our public API. So what I mean to say is the end users can just reference this single file to use all of the functionality. So let me show you how we can do this. Let me take out all of these things. These are not required. Let me collapse the sidebar and let us define a function for our population mean right over here. Now this function receives the list of our numbers, and from here we can simply call our function of population mean. So we can say that we want to create an alias for our stats.centralTendency.mean, and for this function we can simply delegate it to mean.population mean, and let us pass the argument of numbers. So now we have simplified our API quite a lot. Now let me open up the terminal. Let us recompile the module of stats. Let me clear up everything. Now what we can do is we can simply call stats.population mean and let us pass the argument of 10, 20 and 30, and we get back the right answer. Now let us go back to our code and we can do one slight improvement for this one. Now instead of just calling this function, we can use something which is called as def delegate. So first let me show you and then I can explain it to you. So here we can use the new keyword called as def delegate. The first argument is the name of our function. So the name of our function is population mean. So let me paste it right over here. Now this function also accepts one argument, and the argument is for the list of our numbers. And now what we want to do is we simply want to delegate this function to our module of mean, and that's it. Line number 4 and line number 5 does the exact same thing. So let me comment out this line. This is not required. Let me open up my terminal. Let us recompile the module of stats. Let me clear up everything and let me call the same function one more time. And as expected, this is working just fine. Let us create one more def delegate for the sample mean. So here we simply have to change the name from population mean to sample mean. So whenever we call stats.sampleMean, this function will be delegated to mean.sampleMean. Let me open up my terminal. Let us recompile the same module. Let me clear up everything, and here I can say that stats dot, this time I want to calculate the sample mean, and let me pass the argument of 3, 4, 5, 6 and 7, and this time we get the answer as 5. Well, that's it for this video, and I will catch you in the next one. Let us get started with our statistics project. So let me open up my terminal and let's create a new mix project. So let me go inside my folder of functional programming with Elixir, and then let me go inside my folder of code, and right over here I want to create a new project. So I can say mix new stats, and let me open up the folder in a new window. So this is going to be our new statistics project. So let us see how we can implement our population and sample mean functionality. So the first thing is inside the folder of lib, let me create a new folder and let me call that folder as central tendency. Now inside this folder, let us create another file. So let me create a file, and this is going to be for calculating our population and sample mean. Let me collapse my sidebar, and first let us define a module. So this is going to be stats.centralTendency.mean. So here first let us see how we can calculate our population mean. Now the formula for calculating the population mean is very simple. We simply have to take the sum and we have to divide that sum with our count. Now in terms of statistics, this sum is also called as sigma. So let us see how we can calculate our population mean first. So let's define a function called as population mean. This function accepts a list of our numbers, so we can call the argument as numbers, and let us see how we can define the body for this function. But before we can define the body, here we need to do a lot of validation. The first validation that we need to do is we need to check if this numbers is actually a list or not. So for this, we are going to use a guard. So let us go to the official documentation and let us try and see if we can find the right guard or not. So inside the module of kernel, we have a section for guards. So let us check if we can find the guard for list or not. So if I scroll a little bit down, here we have one guard, and this guard is right over here, is list. So let us see how we can use this guard in our function. So here what we can say that we want to have a guard saying that is list, and let us pass the variable of numbers. So basically what we want to do is we want to run this function only when this numbers is a list. Now we have validated that this numbers is a list. But what happens if this numbers is not a list, or in case the numbers is an empty list? So let's define one more function overload on the top. So here we can define that we want to define the same function population mean, and in case if we get a blank list, then at that time return back a blank list. Now we can either return back a blank list or we can also return some kind of an error. So for example, if you want to return some kind of an error, so we can return back a tuple and we can say that this is going to be an error, and we can also return back a message saying that invalid data type. So it's up to you. If you want, you can return back a blank list or you can return back an error tuple. So this is just for your reference. So now let us see how we can define the actual body for our population mean. So here we need to do two things. First, we need to find out the sum or the sigma, and then we have to divide by the count. But before we do all of these things, we need to do one more validation. So till now what we have validated is that this numbers is just a list. But we also need to validate that this is a list of numbers. So let us see how we can validate this one. So here let us create a pipeline. So here we can say that first I want you to take the numbers, and then I want you to pipe this numbers inside a function, and we can call that function as validate our number list. So we have not defined this function, but let's define it right over here. So let me just copy this one and let us define a function right over here. So validate our numbers list, this accept our list of numbers, and let us see how we can define the body for this one. Now for this function, let us return back a tuple. The first condition would be either true or false. The second condition would be the numbers. So in case if this list is not a list of numbers, we will send back false. But in case this is a valid list of numbers, then we will send back a true right over here. So let us see how we can do this thing. Unfortunately, it's very simple. So here let us use the inbuilt module of enum, and I want to use the function of all. Now this all takes two arguments. The first is going to be our enum. So let us pass the enum of our numbers, and this also takes a function. So let us define a function right over here. Now what happens for each iteration, we are going to receive an element from our list of numbers, and we simply have to check if that element is a number or not. So here we can use an inbuilt function called as isNumber, and let us pass the element to this one. And that's it. We have defined a function to validate all our numbers as well. Let us also write the type specification for this function. So here we can say that the specs for validate number list. So this receives a list of our numbers, and this function returns a tuple. The first is going to be our boolean. The second element is our list of numbers. Let us go back to our function of population mean. So now we have all of the validation in place. Now this function returns back a tuple. So what we can do is we can simply take that tuple and we can pipe the output in yet another function. So let us call the new function as calculate population mean. So we have not yet defined this function, but let's define it right over here. So here we can say that define calculate population mean, and let us write the do and the end blocks. Now this function of calculate population mean receives a tuple, right? The first is our condition, the second one is our list of numbers. Now this condition can either be true or it can be false. So suppose we have a true condition, then we can have a pattern match right over here. But in case if it is false, then we can create yet another clause. So let me just copy and paste this one. So here I can say that in case the argument is false, and we don't have to do anything with numbers, so let me replace numbers with my underscore. In case the first argument is false, that means the validation has failed. So here we can again send the same tuple error. So let me copy this one and let me paste it right over here. Now let us see how we can calculate the population mean in case the first argument is true. Now here the formula is very simple. First we have to take the numbers. Next we have to calculate the sum, and we can calculate the sum by using an inbuilt function. So we can say enum.sum. The next one is we simply have to divide the sum with the count. So for this, let us define one more function and let us call that function as mean. So this function is going to receive two arguments. The first argument would be for the sigma, which comes from this one. The second argument would be for the count, and we can pass the second argument right over here. So we can say enum.count and let us pass the list of numbers. Now let us create this function right over here. So we can say define mean. The first argument is for the sigma, the second argument is for the count, and for this one the implementation is very easy. We simply have to divide the sigma with the count, and that's it. We have implemented population mean. But we can do a lot of improvements. So as you can see, we have some repetition. We have this tuple of error here as well as on the top as well. Let me also put some separator lines for our convenience. So this is going to be a separate thing, and calculation for the population mean is going to be a separate section, and one for this one as well. So now let us go to the top and let us see how we can improve our code. So now the first thing is we have this error tuple twice. So let's create a separate module for errors. So let me open up my sidebar, and inside the directory of lib, let me create a new module called as errors, and let us define the module as stats.errors. Let us define a function over here. So we can say define invalid data types, and we simply want to return back the tuple. So let me go back to the file of mean and let me just copy this line. Let us go back to our errors file and let me paste it right over here. Now let us go back to this file. Let me collapse my sidebar, and now what we can do is we can create an alias on the top. So we can say that let us create an alias for our stats.errors, and we can replace this line with errors.invalid data type, and we can do the same thing right over here. So let me take out this line and we can say that errors.invalid data type. Now I want to do one more thing. I want to take out this function of validate into yet another module, and this is because I simply know that we would require this validation function for our future implementation as well. So inside lib, let us create one more file for validators. Again, let us define the module, and the module name has to be stats.validators. Let us go back to this file. I simply want to cut everything out. So let me take it out. Let us go to our file of validators and let me paste it right over here. Now for this one, we can do one slight validation since we have taken this file inside another module. So here we can do one small validation as well. So let's define a guard over here. So when is list for our numbers, and in case if this validation fails, then let us create one more clause right over here. So here we can simply ignore the argument and we can simply return back an error. So let me again create an alias for the error right over here. So let's create an alias for our stats.errors and let us return an error right over here. So here we can say that errors.invalid data type. Now the specification for this one is going to change. So this function of invalid data type, this returns a tuple. Let us define a specification for this one as well. So let us go to errors, and here we can say that the specification for our function of invalid data type. So this function does not accept anything, and this simply return backs an atom, and the next argument is of the type of string. So let me copy all of these things. Let us go back to our file of validators. So now what's happening is, in case if this number is a list of numbers, we send back a tuple, but in case the validation fails, then we simply send back an error, and the format for the error is we have an atom and we also have a message, right? The next thing is, since we have taken this function in a different module, let us go back to our module of mean and let us create an alias on the top. So here we can say that we want to alias yet another module. So we can say that we want to alias stats.validators. Now what we are doing is we are importing errors and validators from the same module of stats. So we can create an alias on the same line. Let me show you how. So we just have to wrap this inside our curly brackets and we can say that we also want to create an alias for validators as well. Now right over here on line number 10, this function is inside our module of validators. So validators.validate numbers list. Let me take out these lines. Let me open up my terminal and we can go inside our IEX. Let us create an alias for stats.centralTendency.mean. Let me clear up everything and let us call our population mean. So we can say population mean and let us pass 10, 20 and 30. And as expected, we get back the answer as 20. Now let us pass an empty list and see what's happening. So in this case, we are getting back an error saying that error invalid data type. Now watch what happens if we pass some other argument. For example, if we pass A, B and C. So in this case, we get an error saying that no function clause matching. And this is because we have not defined a catch-all clause for this function of population mean. So let us define one clause right over here. So here we can say that define population mean. And in this case, we simply want to ignore the argument and we simply want to return back our errors dot invalid data type. Let me open up the terminal and let us recompile our module of mean. Let me clear up everything and let us try the same statement one more time. So this time we get a nice error saying that error invalid data type. So this is how we can create population mean. But we are not yet done. We also need to implement the sample mean. But luckily the formula for sample mean and population mean is the same. So let us very quickly implement our sample mean as well. Let me take out all of the comments. I don't need the comments. Let me paste the separator line on top. Now here let me again copy this separator line and let us create one more function for sample mean right over here. So here we can say that we want to define a function for our sample mean. Now this function accepts a list of numbers and we simply have to call our population mean and pass our list of numbers. So that's it. Now we have the function for sample mean and population mean as well. Let us also define the specifications for this function. So here we can say that the specifications for our population mean. Now this function receives a list of numbers and this function is going to return back a number or it is going to return back an error. Now the type of our error is like this. The first element is the atom and the second element is of the type of string. Let me copy this specification for our sample mean as well. Let me paste it right over here and let me change the name from population to sample. Next we can do a couple of more improvements for our code. Now if you see this function of calculate population mean and this function of mean, so these functions are just our private functions. So let us declare them as private. So this becomes our def of p and this also becomes our private function. The same thing happens for our mean as well. This also becomes our private function. Now let me open up the terminal. Let us try and recompile this one more time. Let me clear up everything and let us try to invoke the same function one more time. Let us pass the list of 10, 20 and 30. So this is for the population mean and let us try the same thing for our sample mean as well. So let me replace this with sample mean and we get the same answer back. Now what's happening is every time we have to create an alias, but instead what we can do is we can separate our public API from our private API. So if I open up my sidebar, we have a module for stats.ex and as you can see that this file is not doing anything. So what we want to do is we want to make this stats file as our public API. So what I mean to say is the end users can just reference this single file to use all of the functionality. So let me show you how we can do this. Let me take out all of these things. These are not required. Let me collapse the sidebar and let us define a function for our population mean right over here. Now this function receives the list of our numbers and from here we can simply call our function of population mean. So we can say that we want to create an alias for our stats.centralTendency.mean And for this function, we can simply delegate it to mean.population mean. And let us pass the argument of numbers. So now we have simplified our API quite a lot. Now let me open up the terminal. Let us recompile the module of stats. Let me clear up everything. Now what we can do is we can simply call stats.population mean and let us pass the argument of 10, 20 and 30 and we get back the right answer. Now let us go back to our code and we can do one slight improvement for this one. Now instead of just calling this function, we can use something which is called as def delegate. So first let me show you and then I can explain it to you. So here we can use the new keyword called as def delegate. The first argument is the name of our function. So the name of our function is population mean. So let me paste it right over here. Now this function also accepts one argument and the argument is for the list of our numbers. And now what we want to do is we simply want to delegate this function to our module of mean and that's it. Line number 4 and line number 5 does the exact same thing. So let me comment on this line. This is not required. Let me open up my terminal. Let us recompile the module of stats. Let me clear up everything and let me call the same function one more time. And as expected, this is working just fine. Let us create one more def delegate for the sample mean. So here we simply have to change the name from population mean to sample mean. So whenever we call stats.sampleMean, this function will be delegated to mean.sampleMean. Let me open up my terminal. Let us recompile the same module. Let me clear up everything and here I can say that stats dot this time I want to calculate the sample mean and let me pass the argument of 3, 4, 5, 6 and 7 and this time we get the answer as 5. Well, that's it for this video and I will catch you in the next one. Now let us move on to the next part and let us see how we can calculate something which is called as a median. Now what I've done is behind the scenes I have created a new file called as median and I have also defined the model for this one. And to make things simple, I have added a lot of documentation. So let us see what do we exactly mean by the median. So let us have a look at this scenario right over here. So suppose Louis is selling candies for 9 hours and these are the sales of the candies for each respective hour. For the first hour, Louis could sell 10 candies. For the second hour, Louis sold 40 candies. For the third, he sold 20 and so on. So these are the number of candies that Louis sold each hour throughout 9 hours of his shift. Now let us see what do we exactly mean by median. So median is nothing, it is just a central value or it's just the value that divides the measurement into two equal parts. So what do we want to achieve is we want to find a value that will divide our measurements in the first 50% and the next 50%. And it's very easy to calculate median as well. So this is going to be a very simple algorithm for calculating the median. The first step in our algorithm is sorting our list. So here we can see we have a sorted list of all of the sales of candies for the first 9 hours. For the second part of our algorithm is we need to count the number of elements inside our list. Now here there can be two things. First, if our count is odd and the second one is if the count is even. Now if the count is odd, then the things are very simple. We simply take the middle value and that value becomes our median. So for example, in this case, 50 is right at the center. We have 4 values to the left and we have 4 values to the right. So 50 becomes our median. The next scenario is what happens if the count is even. At that time, what we do is we take 2 values from the center. So in this case, 40 and 50 are 2 values. Now just have a look at this list. This list contains only 8 values. I have taken out the last value of 90 from this list. Now since this is an even list, we simply take 2 values from the center. So we have 40 and 50 as the center. So as you can see, there are 3 values to the left and we have 3 values to the right. And then we simply average them out. So 40 plus 50 divided by 2 and we get the answer as 45. and 45 becomes your median value. So this is how we are going to implement our algorithm for calculating the median. So let us see how we can translate all of these things into code. So let me go to the top, and here we can see that I have defined a module by the name of stats.centralTendency.median. And now let's get started with this one. Let us define the very first function, and let us call the function as median. This function is going to accept a list of our numbers, so we can call the argument as numbers list, and let us also use the guard right over here. So we can say when is a list, and let us pass the argument of our number list. So this is one scenario, and the next scenario could be we don't get a proper list over here. So for handling that case, let us define one more version. So we can say median. We simply want to ignore the input, and we simply want to throw an error, but first we need to create an alias, so it's very easy for us to use those modules. So let me create an alias for our stats.errors, and here we can say that we simply want to return our errors.invalid data type. Now let us go back to this function and let us see how we can implement this one. So the first thing is we need to validate our list of numbers. So again, let me create one more alias at the top. So here I can say that we want to create yet another alias, and this time it's for stats.our validators. And now let us go down right over here. So here what we can do is we can simply take the list of our numbers, and then we can pipe this list of numbers inside our validators.validate numbers list. And after we validate our numbers list, then we can pipe the output into yet another function by the name of calculate median. Now we don't have that function as of now, but we will create it shortly. Let me put a separate line over here, and here let us define the function of calculate median. Now let me scroll slightly up so that everything is visible. Now let us see what this function is going to receive. So the output of this function validate numbers list is going to be piped into the function of calculate median. And as you can see, this function either returns a boolean and our numbers list, or it returns the atom along with the error message. So let us pattern match on various scenarios and let us see how we can handle different cases. The first and the most easiest one is just to handle the error. So in case we get an input like this, we get an error and the second argument is a message. At that time we can simply return back the tuple of error and the message as it is. Or what we can do is we can simply use the errors module. So either you can do this, or we can simply call errors.invalid data types. Now let us see what more we can do with this function. Now the function of validate numbers list can also give us a tuple where the first argument is a boolean and the second argument is the list of numbers. So let us pattern match on this scenario and let us see how we can work with this one. So let me define yet another function. Oh, one more thing. What we can do is we can simply mark this function to be private. Now since this is going to be our helper function, we don't want to expose the functionality outside. So I am simply marking this function as a private function. Now let us have one more pattern match right over here. Now what happens if the first argument is false? So at that time we can simply ignore the second argument. We don't want the second argument. So in this case also, since the validation has failed, let us again send back the error. So we can say errors.invalid data type. Now let us define the third scenario as well. So again, let us define the private function, calculate median, and this time it receives a tuple where the first argument is true and the second argument is our list of numbers. Here let us see how we can define the body for this calculate median function. Let us go slightly up and let us have a look at our algorithm. So for the algorithm, we need to do two things. We need to sort and we also need to count. Now let us implement those steps in this function right over here, calculate median. So here what we can do is we can take the numbers list and we can sort it out by using the inbuilt module of enum. So we can say enum.sort. So now we have a sorted list of our elements. Now the second thing is we need to count if the number of elements are even or odd. And depending on that scenario, we have to handle two different scenarios. So the first scenario was how to calculate the median when the count is odd. And the second scenario was how to calculate the median when the length is even. So for this, we would need to create yet another helper function. So what we can do is we can take the output of enum.sort and let us pipe that output in one more function by the name of getMedian. Now we don't have this function, but we will create it shortly. Now this function of getMedian is going to receive three different parameters. The first parameter is obviously the sorted list. The second parameter is going to be a Boolean value. So we will check if the number is odd or even. And the third argument would be the count itself. So let us pass the argument for this function. Now the second argument is going to be a Boolean value, and we can check if the count is odd or even by using yet another inbuilt module by the name of integer. So we can call the inbuilt module of integer, and here we can use the inbuilt function of isEven, and let us pass the count. Now for calculating the count, what we can do is we can say numbers list, and we can pipe this one into another function called as enum.count. The next argument for the function of getMedian is going to be the count itself. So here again what we can do is we can say numbers list, and we can pipe the output into enum.count. Now as you can see, we have a little bit of repetition. So what we can do is we can take this one out from here, and let me create a variable called as count. Let me put it right over here, and we can simply replace this by the variable of count, and this also gets replaced by the variable of count. Now the last thing to do is we simply have to define the function of getMedian. So let me use the separator right over here, and let me create the function of getMedian. Now this function receives three parameters. The first parameter is our list of numbers. The second parameter is actually going to be a Boolean value. So let me write bool for now. And the third parameter is going to be count. Now let us see what we can do with this function. Now for this function, we again have two scenarios, right? So if we go back to the algorithm, so the first scenario is odd and the second scenario is even. So what we can do is we can simply use pattern match right over here. So this integer.even is going to give us a Boolean in the terms of true and false. So here what we can do is let us pattern match on false. So that means this list is not even. That means this list is going to be odd. And since this list is going to be odd, we simply have to take the element at the center and return it back. And fortunately, it's very easy. Again, for this, we are going to use the inbuilt module of enum, and there is an inbuilt function called as at. So this function accepts two different parameters. The first is obviously going to be our list of numbers, and the second parameter is going to be the index. So for the index, what we can do is we can simply take the count and we can divide that count by 2. Now there is one small issue over here. So this count divided by 2, this actually returns back a float, and the index value cannot be float. So suppose if this value returns an integer such as 4.5, so in that case we don't have any values, or rather we don't have any index called as 4.5. So what we need to do is we need to have an integer division and not a float division over here. So in order to ensure that we get back an integer, we can use the inbuilt function of division. So the first argument is going to be the count, and the second argument is going to be the number. Now again, this function has to be private. So let me put it as def and p. So this is the first scenario where the list is odd. The second scenario is what happens when the list is even. So let me just copy all of this and let me paste it right over here. Now for the second scenario is the list is even, so we get a true right over here. And let us see what we are supposed to do in this case. So if we go back to the algorithm, so in this case we have to take two values from the center, and then we simply have to divide them by 2 and return back the value. So let us do exactly those things right over here. Now what we can do is let us create two variables to hold the values from the center. So we can say that the first variable is a, and let me copy this function right from here. Now in this case we have to take one previous value, right? So if I go back over here, we want to take the value which is right over here. So what we can do is we can say count minus of 1, and let me again copy and paste. For the next value we don't need -1, and let us call that variable as b. So now we have both the values from the center, and we simply have to add a plus of b, and we just want to divide them by 2, and that's it. Now as soon as I saved my file, we can see that we are getting a small error right over here. So what is this saying? That you must require integer before invoking the macro. So what's happening is Elixir is actually using a macro. So macro is a kind of a code that generates yet another code. But for now we don't have to go into the specifics. We just have to do whatever this error message is telling us. So if you just refer the message, it is saying that we simply have to require integer. So let's do exactly the same thing. So let me go to the top, and here I can say that I want to require the module of integer, and that's it. Now the error should be gone. Yes, now all of the errors are sorted out. The last thing is, let us go to our public API. Let us go to lib, and under lib let us go to the module of stats, and let us create a def delegate right over here as well. Let us use the macro of def delegate, and we can say that we want to define the function of median. Now this function accepts the list of our numbers, and we simply want to delegate this function to the module of median. But before, let us create an alias right on the top. So what we can do is we can import different modules on the same line. So we can say that I also want to import median right over here. Now here on line number 9, we simply want to delegate the execution to the module of median. So now let me open up my terminal, and let me go inside IEX, and let me clear up everything. So here let us try and invoke that function. So we can say stats.median, and let us create a list right over here, and let me pass the values. So as we can see, we are getting the value as 50. Now what I have done is, this is a list of our odd numbers. Next, let me pass one more list which has even numbers. So let me take out 90. I don't need 90 from here. And in this case, we are getting the value as 45. Well, that's it for this video, and I will catch you right in the next one. Hello and welcome to the last video of this series. So the last video is all about learning something which is called as mode. Now what exactly is a mode? So let me try and explain. But before that, what I've done is, behind the scenes I've created this file mode.ex inside central tendency, and let us see now how we can find the mode of our elements. So what exactly do we mean by mode? So mode is basically the element which repeats most often. So for example, if we have this array of values, then the mode of this values would be the values that are repeating the most. Now in this example, the most repeating values are 4 and 8. That's why the mode of this is 4 and 8. Now you must be thinking, what is the use of mode? So let me try and help you why mode is very important. Now suppose these values actually stand for the product ID of the candies which Louis is selling. So for example, 1 could be the product ID for the red candies, 2 could be the product ID for the yellow one, 3 could be for the green one. So by finding out the mode, we can understand which candies Louis was able to sell the most. So in this example, we can say that the candy with the ID of 4 and the candy with the ID of 8 were the most popular candies inside the store. So let us see how we can find out mode. So I have given the steps over here. So it's basically a 3-step process. The first is we have to find the number of occurrences or the frequencies. Next, we have to find the maximum number of occurrences. And finally, we have to group the elements which have the maximum occurrences. Now, instead of directly writing the code this time, let me show you inside the IEX how you can find the solution for this one. So let me just copy this one and let me open up my terminal. So let me go inside my IEX and let me clear up the screen. Now, if we refer to the steps, the first step is we have to find the occurrences or the frequencies. So let me paste the values right over here, and we can find out the frequencies by using the inbuilt function. So we can pipe these values to enum.frequencies, and here it is. So now we have all of the values and their frequencies as well. So what I would like to do is I would like to simply save this in a variable called as ranked map. So now we have a ranked map. The next step is we have to find the maximum number of occurrences. So let us see how we can do that. Let me clear up my screen. So now we have the ranked map. For finding out the maximum number of occurrences, what we can do is we can take the ranked map, and from this map let us simply take the values. So we can say map.values, and let us see how it looks like. So these are just the values. The next is we simply have to find the maximum value out of this map. So what we can do is we can pipe this one into yet another function called as enum.max, and here it is. So the maximum number any value is repeating is thrice. And if we refer to our map, we can see that 4 is repeating thrice and 8 is also repeating thrice. Now there is a small caveat for finding out the mode. In case the elements are not repeating more than once, in that case we can't find out the mode. But if we have elements which are repeating more than once, only in that case we can find a valid mode. So now let me do one thing. Let me copy this one and let me save this into yet another variable called as max. Let me clear up all of these things. So now we have the ranked map and we also have the maximum count. The next step is we simply have to filter this ranked map for the maximum number of occurrences. So in this case we saw that 4 is repeating thrice and 8 is also repeating thrice. So we simply want to filter it out. So let us see how we can do this. So for this what we can do is we can take the ranked map and then we can use the function called as map.filter. Now this function accepts two parameters. The first is your map and the second is your anonymous function. So let us write a function right over here. Now for each iteration, this function is going to receive the key and also the value pairs from our map. And for each iteration, we simply want to filter out for the values where the value is equal to our maximum count. So now we have a filtered map. The next step is we simply have to take out the keys and that's it. So let us see how we can do that. So we can take this exact same expression and then we can say that we just want to take the keys from our map, and that's it. We have our final answer. So let us go back to the code editor and let us see how we can do all of these things right over here. Now for this example, I am not going to do all of the validation and error reporting because I suppose you know how to do all of those things. So let us directly go inside and see how to write the functions for our mode. So let me take all of these things up and here let us define a function, and here we can say that we want to define a function called as mode. Now this function receives a parameter which is the list of numbers. So I can simply add a guard over here. So is list for my numbers. Now if you want, you can do all of the extra validation, but for this video I'm not going to do the validation. So the first step was finding the frequencies. So let me create a variable called as ranked map, and here what we can do is we can simply take the numbers and let us pipe those numbers to enum.frequencies. Next what we can do is let us try and find the maximum number of occurrences. So for that, what we can do is we can take the ranked map, we can pipe this function into map.values. So now we have all of the values with us. Next, let us find out the maximum number of occurrences. So we can pipe this into yet another function, enum.max. So now we have the ranked map and we also have the maximum number of occurrences. Now the last thing to do is we simply have to filter out our ranked map. And for that, let us create a helper function. So here, let us pipe this into yet another helper function by the name of mode_func. Now this function is going to accept two parameters. The first parameter would be for the maximum number of occurrences, and the second parameter would be for the ranked map itself. So let me define a private function, mode_func. Now this function accepts two parameters. The first parameter is for the maximum number of occurrences. The second parameter is for our ranked of map. Now here we need to take care of one more condition, and that is we can find mode only if the number of occurrences are more than one. So for this function definition, let us have a pattern match right over here. So we can say that in case the maximum number of occurrences are 1, in that case we simply have to ignore the ranked map because we can't find out the mode, and let us simply return back nil. But in case we have the occurrences which are more than 1, so to handle that situation, let us define one more function overload right over here. So we can say mode_func, and the first parameter was for the maximum value, the second parameter was for our ranked map. So let's take the ranked map, and next we simply have to filter it out. So we can say map.filter, and here let us define the anonymous function. So we can say function. Now for each iteration, this is going to receive the key and also the value, and what we need to do is we simply want to filter it out when the value is equal to our max. And the last thing is we simply have to take out the keys from this one. So we can say map.keys. Now the last thing to do is let us go to our stats.ex and let us create a def delegate right over here. So we can say def delegate. Let us create a function for the mode. This also accepts our numbers list, and we simply want to delegate this to the module of mode. But first let us import it right over here. So we can say we also want to import mode, and this one we simply want to delegate to mode. Now let me collapse my sidebar and let me open up my terminal. Now let us recompile this one more time and let me clear up everything. So now we can call stats.mode and let me pass the values right over here. And as expected, we get back the answer as 4 and 8. Well, this brings us to the end of this course. But before I can say my final words, I wanted to show you a couple of things. Now, if you refer to the code from my GitHub repository, so which is this one, now inside my official GitHub repository, what I have done is I have implemented two more functionality which are under the folder of variability. The first one is about variance. The second one is all about your standard deviation. Now I am not going to cover these parts inside this tutorial series because I think they are more towards your mathematical modeling and statistics. While this course was designed to give you a fair idea about functional programming in Elixir, but I have kept them for a reference. You can refer them and you can see how I am able to model variance and standard deviation for statistics. Well, that's it from me, and I will catch you in the next one. Hi, I hope you really had fun learning functional programming along with me. Now this course was designed to teach you all of the basic constructs of the functional programming language. But Elixir has a lot more to it. The next things that you will want to learn is all about the concurrency and the OTP framework. And after you learn the concurrency framework, then you can go ahead and you can learn the awesome Phoenix framework as well. Now coming back to this course, if you are finding functional programming to be a little difficult, it's not your fault. It takes some time, patience and practice before you can understand functional programming language. But after you get the hang of functional programming language, believe me, you would never want to go back to your object-oriented programming or your imperative programming paradigm as well. So let me conclude this course and let me conclude this video. And do let me know in the comments how do you find this course. And you can also connect with me on my website. It's octallium.com, and also on Twitter. My handle is @Octallium. And if you're feeling generous, you can buy me a coffee. It's buymeacoffee.com/Octallium. And also do let me know if you want to learn some more concepts from me. If you would like to learn OTP framework, the Phoenix framework, or if you would like to learn mathematics and statistical modeling from me, or any other topic that you would like to learn from me as well. So that's it from me, and I will catch you in the next one. Bye.